so yes, I'm Daniel. I work for Wolf SSL. I'm actually also the president of the European Open Source Academy. That's my website, that's my Mastodon. To wake you up a little bit first. So I work on this little thing called curl, started a while ago. So it's basically a small project. We started out, well, I got started with the first sort of precursors to this project in 1996. And back then we had 100 lines of code. Now we're at 180,000 lines of code. So quite a growth. It's been a journey, still is. So we're slightly over 1,400 commit authors in the project, but still not that many on a day-to-day basis. So 20, 25 authors per month, unique. And until then we count roughly, or a little bit more now than 3,500 contributors that have helped out. So people, reporting bugs, running infrastructure, whatever. A lot of people. So I'm just saying it's certainly not just me. And it has then ended up in quite a lot of places. I mean, yes, so servers, all the game consoles, pretty much every TV, all the operating systems, kitchen devices, watches, robots, vehicles, cars, pretty much all cars, motorcycles, big shot games, all the mobile operating systems, routers, music instruments, medical devices, all the streaming things, all the printers, in a lot of places. So we count somewhere around 20, 40 billion installations. A decent number of installations. but this is just curl, right? It's just an example of a open source project that have succeeded. So there are many others, right? So it's not just curl. So pretty much everything today runs like this. So we make something and we build it on top of a huge amount of open source, mostly open source at least. Sometimes the thing on top is not open source, sometimes it is. It doesn't really matter because we build it on this huge infrastructure of open source, like this iceberg. And I need to tell you, and you don't have to point out that icebergs don't float like this. They will actually tip. So, bad analogy, but it's still like that, right? Most of it is open source, even though we might not always see it. Or, you build something perhaps not open source on top of everything else. Or as referred to, right, XACD. So, and I'm not saying I'm from Nebraska, because I'm not, because I have this silly Swedish accent, but there's a lot of us who would identify with that little building block down there, right? So there are many Nebraskans, really, single-person projects maybe that could identify and could be that particular block. So when you do that and you build that little block, maybe you're from Nebraska, there's a lot of things relying on you or potentially relying on you. Then the security part of your work becomes a little bit more important, or at least to some or to most, or depending on how you feel about your project and what you how you think about life. But for me, it's certainly feeling and knowing that, there's a ballpark of 30 billion installations. I want to make sure that the code actually is decent, right? So the world won't burn tomorrow because of my stupid mistakes. I do enough stupid mistakes. But so when we have a security problem, it might be a little bit more important than other problems, right? Or a security issue is more important than a lot of other things, a stupid bug rendering on the website or a user having a problem with understanding an option. Less important, a security problem could burn the world, trumps everything else. At least it does for me. So maintaining open source, in a particular, maintaining open source is a lot of things for many, but the smaller the project is, the more all of those roles in an open source project end up on a smaller amount of people. And in my case, I'm the only full-time employee working on curl, so I get to do a lot of things. So because I can't rely on others. And the world is riddled with one-person open source projects, right? So basically, the median number of maintainers of open source projects in the world is one. So, and a lot of open source is done as a spare time hobby. They're not getting paid to do this. They're actually doing it as a thing on the side. And even if you do try to get money out of it, it's really hard. And a lot of projects are underfunded. And we all have a lot of, echo. And lot of outstanding tasks. So basically, there's a huge demand on a lot of open source maintainers that we should do things, fix things, and keep delivering things to a world that is more and more relying on our code for too less money. So making open source, of course, is not a silver bullet. I mean, how do you actually make secure and safe options, right? How do you actually deliver code that actually works for 20 billion installations? There's no silver bullet, there's no magic here. I mean, you won't actually fix everything by selecting a particular language, a particular model, or particular anything. You just have to do proper software engineering, right? You have a decent infrastructure, you write good code that is easy to read, you review the code that others have written that it looks fine, you have a lot of tests, you do a lot of good tooling on it, you analyze it, scrutinize it, you fuzz it, and you do all the things you can do as an engineer to do good code, because that's what you can do, right? That's what we all can do when we have code, write good code. And one of the things we can do, and one of the things we do in the curl project, we run a bug bounty. And this has typically worked really well. We say, if you can report a security bug in curl, we offer you X amount of money to use that as an incentive for people to actually go and look for security problems, to actually dig around a little extra, maybe spend an extra afternoon to actually check for that bug in curl instead of doing it somewhere else where they wouldn't get any money. So that has been a pretty successful way for us to actually get a lot of quality security work done by people out there, some of them really good people. And it has worked then. So we basically pay monetary rewards for a confirmed security vulnerability. And that has really motivated people, and we actually then also motivate a few that do this professionally, right? There are a bunch of people who actually are professional bug bounty hunters, right? That's their work. They don't do anything else. So they go around and look for projects that actually pay money because they do that to get food on the table. So it has helped us to actually attract those who do that as a profession. Cool. And finding and fixing bugs is, of course, good stuff, right? I mean, it is soul-crushing every time someone points out a bug that is sort of a vulnerability, so that, oh, I did that too. So that, again, I did something stupid. But beside the stupidity, it's good to find the stupid, fix it, and the next version is better, less stupid, and that's good. So aiming for less stupid in every release. And Curl's Bug Bounty then has worked, I think, pretty good. We get 2-3 submissions per week, or we have run this program for a little over 6 years now. And we get about 2-3 submissions per week. That's pretty good. And of course, when you get a submission, that's a submission from a person who thinks they found a security vulnerability in curl. Potentially important, right? Security vulnerabilities, not good. So we spend time, understand what it is, assess the importance, sort of reproduce it, figure out what do you mean, how can it be? Is it really a security problem? Oh, there might be a crash. Is that crash? All of that. There's a lot of back and forth, deliberating, thinking through it. It takes a few man-hours maybe per issue. Usually, the rubbish reports are really quick to dismiss. Someone ran a tool on the code and it found something. We couldn't immediately say, oh, no, stupid. We've seen that 3 times before. You can close it in a matter of seconds, maybe minutes, because rubbish has typically been really easy to detect. Rubbish, throw it out, get on with your life. And we pay up to about 10K per vulnerability if you ever reported a critical vulnerability. No one has yet found one, as long as we have run the bug bounty program, so we haven't done that yet. But we have paid over $93,000 so far to different security researchers for sort of as a thank you for their work and for their good reporting of having found, now at 83 confirmed security vulnerabilities. So I would say quite a lot of security vulnerabilities for not that much money. I mean, comparatively. And of course, I'm fortunate to run a project where we can actually give out money to this amount, because I also understand that a lot of projects don't have this money and don't have this ability. But I'm grateful that we have a sponsor that actually takes care of this. But anyway, so that was 6 years. Yeah, IBB is then the sponsor, the Internet Bug Bounty. They're basically a team of people that we find the problem, they pay the money. So it's excellent setup. I can recommend. It is, as a little parenthesis, it's actually kind of amusing because they also pay us money. Because the idea is then that we should get, a small percentage for the work of fixing the problems, but it's really the old way of, riding yourself a minivan because we get money for every security vulnerability. Okay, but then, recently, or I should say maybe in the last 2 years or so, we had a new fun thing, right? The world of AI has changed things around. Excellent children's book. No, I don't know. I like the cover. So things have changed. So this is basically the whole setup, how it works, right? So now you do this. So now when you want to find a security problem in anything, you ask your best friend, just tell me a security problem in this, and it'll tell you, because it will never say no, right? It'll always say, sure, here it is. And it always provides something that certainly looks and sounds like a real answer. Well, it is a real answer, but is it true or not? In many of these cases, I would say that the one who's asking the question, they don't even really know the answer, right? Because the answer is long, complicated, and it sounds really bad. So, yeah, it really works like this. So one person does this, yay, hey, show me something. And then wham, when everyone does that, we get a lot of slop from all sorts of places. And for all these individuals, it's really easy, quick, and you can do that basically in 20 seconds, and you'll get a huge report that sounds really serious, good, submit it. So that's what we get. And we're in the receiving end. We suddenly get a lot of these. So these problems, I would say, when you ask a chatbot, they basically cannot find a real problem. They're all made up. They're all, sounds reasonable maybe, especially if you don't know the area in particular, and it'll sort of tell you that. So, and how do you know when an AI is, when someone has used an AI to do this? From the beginning, it sort of course, it surprised me a little bit from the beginning because I wasn't really prepared for this avalanche to happen. So I would say that from the beginning, it took me a while to actually understand what we were dealing with. And over time, also the chatbots are changing their nature, so they're actually changing language a little bit over time. And I think also the unfortunate thing is that people are then also mimicking the chat ways of talking, and the other way around, that people are also sort of tweaking the chat's response, right? Because there's always a human involved. There's a human proxy. I mean, these submissions are not made by bots. They're made by humans who have asked the bots. So there's a human involved, and the human involved here can tweak and change the AI responses to a certain degree. So exactly when it's AI, when it's not an exact science. But you know that when they're very, very polite, especially from the first submission, you can be fairly sure that no human ever, starts with a long apologizes, excuse me, but no, that's not how people have ever been speaking before, at least. So that's big, the alert goes off. Wait a minute, why are you starting your submission by apologizing? No, humans don't do that. And especially when following up, when they ask a follow-up question, and another excuse. No human ever does that. Humans are more, direct, and usually, you're stupid, you did this completely wrong. More push us down from the first moment. So you know that when it's very polite, and always this perfect English, no typos. I mean, I certainly never write that. So not that I ever did that, but full of typos and weird phrases. But the AIs are really, really good at English. Everything flows through really nicely. And wait a minute, why are you speaking in mixed case in your title? And everything in mixed case like this. Is this a newspaper title? Everything, always. I don't know why, but the AI is really, really fond of this. And of course, M- is a sort of a classic, because in many cases, it's actually hard for you, when you write normal text, on many computers, it's not that easy to actually make an M-dash or insert. For some reason, they like emojis. So, for example, when the user have asked the AI to write a little reproduce example, it usually adds a few emojis in, if not in the comments, in some kind of print outputs. No human ever did this, but the AI is typically, yeah. So emoji in the print output, wait a minute, did you write this yourself? And of course, they're always too long, literally too long. You get these 400 lines things, with 22 examples, 14 sections with bullet points in them all. This, and as a receiver, at least I've sort of grown accustomed to every time there's a security vulnerability report submitted, it's a little bit of, a pulse increase. Wait a minute, what stupidity did we do this time? Or, oof, this could be a bad one. And then you're starting to read it, and these AI things, they tend to be, well, very alarmist. And yeah, now the sky is falling. This is super bad, severity critical, bad. And and just because of the amount of text here, and written in a good way, and plausibility, blah, and risks, and this could happen, and all of that takes a long time to get through. It's a lot of slop. And the better the crap is, the longer it takes to dismiss, right? Or understand, what are you talking about? And sort of understand, is there anything in here? And of course, yeah, I mentioned it already, bullet point. So no humans ever, and I think this is, unfortunately, I think the AIs are now sort of teaching us all. Every section should at least have 3 bullet points, right? So we have a lot of sections with 3 bullet points in each. You know that no human wrote this. Because why would we write bullet points all the time? No, we don't. So then we know, yeah, sure, it's an AI submitted thing, but is it bad because it was written by an AI? Potentially it wouldn't be. It doesn't. You could, in theory, think that it's a good thing. So anyway, so you get that huge submission, try to make sense of it, you ask a follow-up question, and of course, it's too friendly, it's polite, and you can also be sure that asking a follow-up questions are, did you really try this? And then it apologizes and answers again, 150 lines. So I asked you a simple yes and no question, but here's a huge response. And it's super annoying, right? Because it takes forever. Wait a minute, what do you mean here? And then you have to read it through, analyze. So it becomes a real time sink. It takes forever. And it apologizes all the time. And it easily loses track of where it started. So if the conversation goes on for a while, it might sort of drift off and find a new issue, or start talking about something that it actually didn't start from the beginning, which is super weird, but it has happened at least a few times. Yeah, and super long. So it's a really tedious thing, and you can really feel that since, there is a human involved here, so sometimes you can get actually the follow-up answer from the human, but in many cases I think the human doesn't understand what they're doing, so they're just piping my question back to the AI, so the AI then, and they copy and paste between me, so I'm talking to the AI via human. But it's super stupid, everything. But okay, it could be potential. And sometimes, sometimes people are using translator services, right? So it doesn't necessarily have to be created by an AI. Maybe the AI just translated it for someone. Maybe someone who really can't speak English, so they're actually helping us out here for real. So it could be, sometimes a human can then sound a little AI, even though they're actually not an AI. So I don't want to dismiss everything just because it sounds AI. So it really ends up like this. We're struggling then, we get more and more of these super big reports. And when we do maintaining in an open source project, we do a lot of things, right? And in a small project, of course, a lot of these different tasks end up on a small subset of people. And as I say, sometimes we also do feature development. But yeah, so in my project, I'm the only one who's doing this full time. So I can't really rely on anyone else to just show up and do all of these things that needs to happen in a project for it to strive and move on, and everyone should be happy. And one of these is, of course, then a little bit more important than the others, or viewed a little bit differently. Maybe in a normal, typical day, it could be like this. There's some amount of sleep, there's some amount of life, and there's a lot of different tasks to do in your open source project. And then someone asked me, but why is that more than 12 hours? I don't know, it's a visualization. Anyway, so security work then sort of pops up and is much more important than everything else. So we do a little less sleep, a little less life, and a little less of everything else, and it becomes more and more security work. It's just the nature of security work, right? And the more time the security work takes, of course, the less time we get to do with all the other things. So, just to sort of make it concrete here, this is now a while ago, it was in May, so things may have changed a little bit. Okay, penetration testing report, HTTP3 stream dependency cycle exploit, mixed case. Sounds weird, or sounds fairly important. A novel exploit leveraging blah, blah, blah. And here's a little patch you have to do to run the test server. Apply this on this AIO Quick is a Python quick server. You need this patch to apply to run this test server. Okay, fair, right? We have to reproduce it, so you have to patch the test server, fine. Okay, and yeah, here's the tests, some other test code to run. And yeah, and here's an example. When you run this, curl crashes with the GDB option. He set a breakpoint there in a function, you run it, we get a segmentation fault. This is fairly bad, right? The segmentation fault could be the sign of something really wrong. But, or is it? Wait a minute. So, okay. Signs of memory override, 41, 41, 41 in R15. You know, everything here sounds, yeah, it sounds like you found some kind of segfault core dump crash somewhere. And it runs the GDB on the core file here to, I don't understand what it's doing, but it doesn't matter. So, okay, sounds bad. HTTP3 exploit, let's figure this out. So what's this? Stack recursion at risk summary, bullet points. Of course, and for this, I mean, there's typically just 3 bullet points, but yeah, okay, 4 bullet points. Yeah, risk high, pre-authentication, remote triggerable. Really bad, but as we say, so I got this, I started to read about it, so this sounds really sort of really bad, but wait a minute, the GDB session you saw there, it actually entirely made up because it uses function names that don't exist, and sort of, it looked maybe right, but they're not right, and the registered contents and the stack pointer, it's actually not possible to get them like that. So the crash doesn't happen. So, and really, it's all made up, and basically nothing in here. It was all just, you know, out of thin air, like a movie script, right? He found a problem in a function that we don't have, sort of, and there's no HTTP3 cycle exploit. This is sort of just a, yeah, it sounds like a credible error, but it doesn't exist. We never had one. I don't think anyone ever had one, but 400 lines of report and a follow-up. And then, of course, some kind of excuses or apologizing. Oh, sorry, but how can you actually sort of rectify it? I mean, how can you sort of motivate? Yeah, what did you think this was? And this is just one example. I actually recently got several examples when they would reproduce the bug that they're reporting, actually wrote a reproducer in the same style like that. Right, the patch for the test server, it also didn't apply. So the patch was also just made up. It was not at all. And so everything was just, I don't know. Well, anyway, so recently I got several reports when they asked the AI to write a reproducer, and the AI produces a reproducer, you know. Here's 200 lines of code that reproduces the issue. The only thing is that no code in there uses curl. So, why? Well, I guess that's a sort of a similar thing, that they find something and then sort of lose track of what they actually want to show, and then it shows something, but it wasn't actually the thing they started out. And it's super annoying, and really, really a waste of time and energy for all of us, for all of us who actually try to understand and figure out, and you know. And then we start over, because tomorrow there's going to be another one in this style. And of course, over time, we also become more and more we expect this now, right? So now we expect that what we get tomorrow is going to be another one of these. So now we're sort of, what I previously thought, oh, bad, a security report, is more like, oh, now, great, another slop thing. So no one right now takes any of these very seriously, because most of it is just going to be another stupid invention. And actually, when curl has been, because I have, of course, since it was my baby, I track where curl is used in different movie shows and TV series. I can tell you that they're much better at actually. So in all of these cases, they're actually using curl sort of in a credible, reliable, in a way that actually works for real. So slightly better on TV than in AI worlds. Anyway, so stupidity is not AI exclusive, right? So, I mean, humans have, we have always had, a certain amount of users have always been these, friction in the machine, annoying people, submitting things, and we have always had people run this little tool on your code or on your site and report it to you, right? We always had that, and they've always been annoying, and they still exist. But this new way, right, so I have, and we have this certain amount of people who keep reporting me that they can find my Git repository. That's not a security problem. That's sort of the point. But please, so, this is like 1 in 20 reports. They find this Git repository. Or something else, when they find something in the Git repository and tell us about it, we found blah, blah, blah. Often some kind of test code. There's a password somewhere or something. Yeah, it's in the test case where we test passwords, right? So, or something, this is a favorite, right? If you use curl file : you can read files. Arbitrarily. Thank you. Keep reporting. Well, and we have gotten this many times. It keeps coming. So, and of course, this standard thing: run some kind of tool, find something, tell us about it. That happens all the time, but it has been happening for a long time. In particular, when that tool is usually some static analyzer code or something looks for something. It found an error, they will tell me about that error without analyzing, understanding, thinking themselves for 1 second. So bad, but usually that's sort of, yeah, we know. Thank you. But anyway, of course, this sort of DDoS attack or whatever you want to call it, it could then lead us sort of, we get a little bit of a reduced attention and activity elsewhere when we keep working more and more hours on dismissing the avalanche of crap coming in. So it really risks then that we reject some real problem in there, because sometimes we just get overloaded and get a little bit of a, mostly just snark and sarcasm in the team when we get a new report nowadays. So of course, it's kind of mentally exhausting to just keep on getting a lot of things like this. It could then potentially, of course, cause some supply chain issues. But why do they do this? That's the big question, and people keep asking me that as if I would know, right? I don't know why they do this. No one have ever sort of stood up and told me that we did this for the money, even though I think offering money for a confirmed security report, of course, give them an incentive to actually do this a little bit extra, so maybe the money is some part of it. But I think a large part of these users, they actually think that they're helping out. They've actually they actually bought the myth or the lies that these tools can do this. So, and the tools told them that this was true, right? You asked for something, the tool told you something, sounds really bad, yeah, and they report it. So I think, it's not only the reporters, it's an industry that have told everyone that this is the way they work. They're really good at it. Use them. And nowadays, of course, every time it happens, it's too often because it's annoying and tiresome. But it's now we're reaching sort of half of all reports is now sort of just AI-generated crap. And the rate is also going up, so we're actually getting more reports now. I told you we got 2 to 3 on average per week over time, but nowadays I would say we get 5 or 6 per week. So maybe 2 or 3 of those are AI crap. And of course, AI crap didn't happen at all 2 years ago, because then we didn't have these chatbots. So what we do about this is basically, we of course ban the reporter immediately, but we use HackerOne as a platform for receiving and managing our bug bounty report, which is good and bad, because typically these reporters are first-time reporters anyway, so when we ban them, kind of a slap on the, who cares? They will just create another account tomorrow if they need another account, right? So banning is totally useless. Who cares? That particular account won't report again, but okay, that doesn't make any big difference. And we can sort of report them as a violation of terms of use to HackerOne as a platform. But again, it's oftentimes a first-time reporter. It doesn't make a big of a difference. So we have now, a question in the in the form when you report a bug. Did you use AI to find this? No one says yes nowadays. So basically, I want this question asked so that people would think again and be honest and say that they did. So sort of just to lower our expectations, basically. But the only result is that no one says yes. So no one uses AI. So I don't know why I have this question. It doesn't really help anything. So anyway, we want to remain approachable and open, right? So I don't want to raise the bar a lot to make it much harder to submit these security reports, because they have been helpful. I think they have helped us a lot in the past. Now I'm sort of starting to reconsidering, maybe we have gotten all the good ones. Maybe we need to raise the bar anyway, because maybe we're past that moment in time. But I always I wanted it to stick and stay open and available as much as possible. We'll see. So nowadays, I lean heavily on public shaming. I don't think that helps either, because most of these people actually, there's something special with HackerOne, but all the accounts that ever submits a security report, they always have these cool hacker handles, They're always, a lot of numbers, and there was an elite hacker and with different numbers instead of letters. So public shaming doesn't really work either, because they created that account with a new elite handle when they submitted this. So even though we can all, I can publish it online and we can all laugh at it, but the person actually did this. We don't know who he is, and we can't actually point fingers at. So that person could very well just do it again tomorrow without. There's really nothing we can do easily against that, apart from us having fun, of course, and that's fun too. So nowadays I make sure that we actually disclose all HackerOne submissions to curl, so you can just follow all them, so you can see a lot of those crap. Some of them good, most of them crap. So people have done, well, you should insert some prompt injection in your code, either in code or in comments on HackerOne to sort of trick the reporters to do something. I don't want to do that. I don't want to sort of ruin the code or insert rubbish somewhere. And I think it's a short-term fix, because someone is just going to work around that. And sure, we can use AI to detect AI. But again, the AI is not the problem here. And we see a lot of humans modifying the AI language to just hide it from looking like AI. It's the same rubbish, right? So the problem is not really AI. The problem is that it's too easy for people to submit rubbish, or that the rubbish volume is going up. Or sure, we can add a honeypot so we know that if they report on that, it's wrong, but it doesn't really help, because they will report on everything else as well. And again, the most common thing people say, we should charge money and maybe give the money back if it turns out to be a real problem. But all of you know that charging money is a hassle, especially in an international context. Who's going to receive the money, and how are we going to take care of putting the money back, and administration of all that? It's a hassle, so I really don't want to charge, even though it might be a way to sort of really slow down the submissions. Sure, but it would probably also take away a lot of valid submissions as well. So, and we should work harder on reproducing things in a virtual machine before we accept it. Sure, that's maybe an idea, but curl run on over 100 different operating systems, 28 different CPU architectures. Most people, when they find a problem, it tends to be very niche, very hard to reproduce, and rarely that is just reproduce it in a VM. Yeah, that would be ideal if the world was that easy and simple, but it's not. So we're really, in our case, we're sort of I'm trying to get HackerOne to take this a little bit more seriously, but they, I don't know, occasionally they seem to say that they take it seriously. Mostly they shrug and don't care much. So I would say that it should be a violation of terms of service just to waste time of whoever received this, because it's certainly a time waste, an energy waste, and a waste of everything. And reputation system doesn't work at all. I think only, I have this list, I'll show you in a second. Right now it's like 28 different AI slops that we received curl, and I think one of them was ever submitted by someone who actually had a reputation to begin with. So that was basically the only person who ever cared about us sort of hurting their reputation. So it doesn't work at all. So we rather want some kind of proof of some kind of intelligence or something, or I don't know, require something out of the user, sort of raise the bar something that makes it slower, harder, and really make them submit this report shorter. I want sort of a maximum amount. I just want no more than 100 lines. If you can't state your problem clearly in 100 lines, maybe you should just rethink it and shorten it. I think that would be a really helpful way. I have a conversation with HackerOne, but it's basically every third month back and forth, and then there's silence, so I don't know what's happening, not a lot. And I also want to switch over to have a system with that where HackerOne also doesn't really support this way, so basically have one person to take care of the initial report, you know, the slop handler, so we can just, a single person instead of the whole team getting the first report, just to, so that we only involve the team when it actually is proven to be something. So yeah, they should really take it more seriously. So it's really not about AI, it's the abuse, and the AI makes it so easy. So it's not that it's really AI, it's just that there's a sort of open the floodgates. Here it is, all these is coming. And it's really hard to discern. And over time, of course, the AIs are changing, so the language is changing, and users are involved. So nowadays, and people are also making things harder, right? Oh, no, I didn't use an AI to find this. I used the AI to write the reproducer. Sure, maybe, but, right? And all that, or so people are mixing things up. And of course, I wrote this slide before last week or something. I got a huge report from a good person who actually used some really cool tools using a lot of AI that actually found a lot of credible reports and good findings in curl. So basically proving that my talk here is wrong, but I mean, it shows that sure, an AI can be used for good, you can find good stuff with it, but you need sort of a person, someone who actually understands something, you know, some intelligence involved to discard the bad stuff, get in the good stuff and report that. So sure, it's going to happen. It's going to happen more going forward, I think. I still think that this ordinary ask the chatbot for help is going to be really bad, because the chatbots are not really made for this. And I would imagine that if you know how to do the proper prompt, you might get something valuable out of it. But I don't think these people are using that. They're sort of just, you know, show me a bug report, make it and add, make it sound terrible or something. And we got one of those when they forgot to include the instruction in the beginning. And then, of course, in addition to all of that crap, we have the scraper bots, right? So on the curl website, which is just, you know, curl and some documentation and tarballs, we serve 70 terabytes nowadays per month, which is a huge amount of data. And that's 4,000 requests per second. And we serve about 0.01% of them are tarball downloads. I don't know what they're doing, really. Fastly sort of eating all that bandwidth, so I don't really need to take care of that. But that's a lot of just bots, mostly. So going forward in the future, yeah, I'm sure they will improve. I'm sure it's going to be a back and forth. I think we're going to see a lot of more slop going forward as well, even though some tools are going to improve, and good humans are going to get some quality results out of them. And the companies certainly keep selling us the myth, right? The AIs are really good at everything, just ask them and they will tell you. And humans are certainly not going to improve. we're going to have, I mean, X amount of humans are always going to be the annoying person that we really didn't want to talk to, but they're going to keep being in your projects and reports. And so, well, yeah, we might close it, we might change it, we might do something else. We need to add friction because we don't want, it's too easy now to just send in huge amounts of crap that sort of wastes our time. So whatever it takes, basically, we're going to do. So I have this fun collection. So this is a collection of links to HackerOne reports. Some of them are really, truly mind-numbingly stupid, and you can immediately see what I've been talking about. You know, mixed case, bullet points, lots of stuff made up. Some of them sounds really crazy, but yes. But I'm actually sort of, yeah, this is just what we're fighting against right now. I honestly think and believe that open source will survive in the long term anyway, because we're so many, and we've done this for a long time, and we certainly know how to be resilient and just, you know, thick-skinned and endure and survive this as well. So I'm an optimist in the end anyway. Thank you. Question? Any questions? Or none at all? Just coffee in the back.
Have you found that there are any meaningful do not train tags that you can litter on the website and elsewhere, or do they just get ignored?
No, I mean, since we've given it, this curl is basically an MIT license. So we've given everyone the permission to do whatever they want with this code, pretty much, right? So we can't tell them not to train on this because that wouldn't be a MIT license. So the code is there, so they will train on it, for sure.
Even for the report?
Sorry?
Even for the vulnerability report?
Even for the vulnerability reports. Yeah, but the vulnerability reports are generated by just the ordinary general chatbots things, or whatever AI you're using. They all know about curl. You can just ask it, sort of, find a security problem, and it'll tell you one.
Has there been a single report that was made by AI that actually ended up being correct or led to some actual vulnerability?
Out of these, so as I said, no, I would say that the short answer is, but that was sort of, last week I got the first set of reports that were actually generated with the help of AI-powered tools. That were actually, some of them actually amazingly good. So now I can say none of them were actually security problems. So I can still say that no security problem has been found with an AI tool. But I can certainly sort of, thanks to that, I can see that what you can achieve with really good tooling, right? Sort of static code analyzing taken to the next level because they don't actually need to compile the code, so they can sort of do things differently. Or when they're really powerful, they can do that. But I also think that might just be an exception. Maybe that was the only time. Now people are going to go back to just do this because I still think the main problem here is that it's so easy to just get this crap out of it, and it sounds real.
Thank you.
So GitHub is about to introduce a function, so create an issue with the help of Copilot, you know. So when they told, since I knew about it ahead of time, I showed them this is how it works. So create an issue for curl, find a security problem and report it. Bam. Yes, they found one and they wanted to report it immediately. So it doesn't really matter what kind of AI you use, because LLMs are made like this, right? There's no AI here, there's no intelligence. It doesn't actually know anything. It just it sounds like a security problem, and it'll find one. It doesn't really matter. So if you don't apply intelligence and sort of thinking a little bit by someone, you're going to get a lot of crap. It doesn't really matter. Short-term wise, they're all going to do this. Any more questions? 2 questions over there.
Yeah, one of your slides seemed to indicate you actually have a life. Can you tell us about that?
I need to keep that impression alive, you know.
From my perspective, I believe it's those companies like Veracode and these InfoSec analysts that are getting high-paid positions to kind of, they've got to do something about this red checkbox that showed up in their SCA scan or something, and so they're probably just saying, hey, go turn this green. And I wonder if you're just getting hit by a bunch of InfoSec analysts that just want to throw that task that's landed on their plate over the fence and say, hey, you need to solve this because I got to get a green checkbox.
Yeah, of course, there's some amount, some of that they sort of find something and want it.
You know, it's usually those things like you said, like the file, like yeah, we know it accesses the file, like right, like some of those more basic ones that the scanners are pulling.
Yeah, maybe. It's a weird. As a receiver of all this, it just makes you sort of wonder, sort of question mankind in general, because it's just so stupid.
Thank you. Very nice speech. Thanks a lot. And assuming that the bug bounty in the end got successful, which means that the person get paid, I guess there is a binding between the submission and the identity of the person, right? So wouldn't it be possible to have like this binding ahead, before?
Possibly, yes. I mean, that goes back again to what HackerOne can do about it.
Mm-hmm.
So yes, I agree. But from my point of view, HackerOne can do a lot of things here to make this better. I just don't feel that they think this as annoying and burdensome as I feel. So that's sort of a little bit what I alluded to. When I talk to them, I say, you should do something about it. And then they answer me back 3 months later and say, yes, we should. And I answer them again, okay, what do we do? And they take another 3 months and say, here's some things we're thinking about. And I say, what about this? And you know, so yeah. Maybe by 2029, there will be some cool new things. So, okay. And I suspect, even though this is not my public opinion, but I suspect that they're earning money from this, because they have a monetary incentive here to, you know, help projects get rid of this. So I think you can buy the service from them. So I'm not sure they're very eager to sort of reduce the friction too. So I don't know. I think they're playing both sides in this game. So I don't know.
Thank you.
You mentioned this is a bigger issue still because you're addressing everything. You're addressing the code, the website, distribution pack, and a lot of other things. Is there nobody else that can like tackle at least the initial review of this, because there's no volunteers, nobody's knowledgeable, there's no budget? Or
yeah, but that's a little bit, that's why I want to go to a system where we have like one single triager of the initial issues to make sure that we don't burden everyone. Because I think in general, security, I mean, security is hard in general. Everyone who's ever worked in something that is related to security knows that it's really hard. And judging when something is a security issue or not, it's not for anyone to just, I cannot just bring a newbie into the project and, hey, you're going to be the one who tells me if this is a security problem or not. It's going to take a lot of experience and keen eyes and knowledge of the architecture and of a lot of things to be able to tell that. So So I can't just do that to anyone. So it needs to be someone who's really skilled, and not to talk about the sort of the private nature of them in the beginning and so on. So I don't see how we can, because I get a lot of people who are then asking me to become volunteers to do the first judgment call, is this AI or not, to sort of take away that work from us. But I don't think that's a sort of a reasonable way to go ahead, because I think it takes a lot of experience, knowledge, skill to be able to do that. Apart from the most stupid AI things, you actually have to read it because it might actually be right. And the entire problem with this is that it might actually be right. We cannot just dismiss it. This sounds like AI, throw it out. No, we actually have to read it because it might be right. And there we have another one.
So I guess more a comment in some ways. So in FreeBSD, we don't currently have a bug bounty system in the same way. So we have not really seen, to my knowledge, a lot of slop in our bug busting system. We do get a little bit on GitHub submissions sometimes. They tend to be like, we're going to do a bunch of style fixes, and so we just kind of, we don't bother with trivial code submissions in effect because they're too much work. But the one place that we did get a lot of it this year was GSOC. And in fact, it seemed to be kind of Summer of Code project-wide, which is another place where money's involved, to the extent that, like, at the end of GSOC this year, Google emailed all the mentors with a, with a survey, and as part of the survey, they said, yeah, we know that basically everybody got inundated with a lot of AI slop in their submissions that required a lot more work to navigate. So I do think the money is a factor, because that would kind of explain why, in our case, we don't get it in places where we're not offering bounties, but like GSOC is a big bounty in essence, and it got inundated not just with FreeBSD, but kind of across the board among all the organizations that were doing GSOC. And I don't know how Google's going to help that. I think they have even if HackerOne is not profiting, they don't pay the cost, right? You're the one who pays the cost of evaluating if something's bad or not. And I think like the same thing happens in GSOC, where the organizations who are evaluating things come in, Google's not the one paying the cost of the slop, right? Because it doesn't cost them anything to have more submissions come in. So I don't know how they'll address it either, because the incentives don't line up. I mean, I think out of the kindness of their heart, they may try to address it, but that's the only incentive structure they have to try to, why they might want to address it is that. Because they're not the one paying the cost. We as the projects are the one who pay the cost for dealing with it.
I think, so the example I'm doing here with AI slop for the sort of curl security reports, this is just one example of a lot of AI slop flooding, right? It's AI slop everywhere. So this is just one particular niche. Everyone who's working in anything, as you say, where you sort of accept something coming in a little bit too openly or easy access, everyone is going to see a lot of incoming slop, because every producer, every user out there is going to use these AIs because it's so easy for them to just enhance everything and enlarge everything, and you get more bullet points. So absolutely, geez, all of those open applications, grants. I mean, we hear this from all sources everywhere. People are accepting papers, everything. There's going to be a lot of more slop everywhere. So I'm not suggesting that I'm unique or special in any way. This is just one example of how it sort of turns out. I think we're done. Hey, I have some curl stickers too if someone want to get one outside.
We have a little speaker gift for you.
Okay.
It's a tie, but consider
About OpenBSD. Do you have any questions? No, but seriously, so for this kind of talk, I'm thinking maybe it's best if you just shout in the questions when they arise, not keep them to the end. Maybe that will actually work out. A bit about myself. So I've been touching computers professionally for nearly 3 decades now. I'm a professional sysadmin and DNS operator. I'm currently working at the EuroBSDCon for the last bit over 10 years, where we are running what is arguably critical infrastructure. So we are serving the DNS root zone and a bunch of infrastructure domains, like all DNS reverse delegations. And one thing as a sysadmin I learned is complexity is the enemy of uptime. And we do strive for 100% uptime, and we usually achieve that by basically running our DNS servers as nearly 200 independent servers, and they are spread over all continents except for Antarctica. So if you have a pop there, please talk to me. We can do something about that. And so this is an anycasted network, so if one node goes down, something else just takes over the slack. And of course, these servers are not artisanally crafted. They're all the same. We automate what needs automating. We are a lazy bunch. We don't want to get excited at 4 in the morning. And we also do not push all the buttons. This is particularly interesting currently because I'm working on ISO certification and NIS2 compliance. And if you're making a change and an auditor asks you, hey, why did you make that change? Well, it seems like a good idea at the time. No, that's not going to go down well. Don't do that. Unfortunately, we are not running these things on OpenBSD. So then also not another BSD. So the question then is why I'm here. Well, I'm also an OpenBSD developer for the last 13 plus years. I've been basically all over the place. I found my niche in privileged separated network daemons, configurations, and I've done a bunch of presentations on that in the past. I've also worked on sysupgrade, so that's basically my fault that that thing exists. And I think my greatest achievement was deleting 300,000 lines of code, which actually brings me to having deleted more lines of code than added. Thank you. So we used to have IC's bind in base as a name server. We switched to NSD and unbound. But we kept the source code around because we wanted the dig, host, and NS lookup tools. And it turns out that those are actually thin wrappers around a fully fledged recursive resolver. But once you start to dig into that, it turns out you don't need all that crap. You can really delete a lot of stuff. And so you're deleting and you're digging deeper, and suddenly you find, hang on, there are like 4 abstraction layers until you actually hit POSIX and libc. So they have their own time functions, they have their own string functions, they have their own memory allocator. Well, that's actually not true, they had 4. And we really had to, no, you're not getting to do that. They also had threads in there. No, really don't. So another quote. The operating system is only free if your time has no values. So this one has been around since the 90s, and this was about a specific operating system, which was not a BSD operating system. But I think this is true for all of them. A BSD can annoy me as much as the other thing. So, and my time does have value, so I want to do something about that. Running my own infrastructure, because I found that's easier than renting something somewhere. And as a professional sysadmin, I learned, well, I want to automate things, so I'm doing that. This is currently done with Ansible, which seems to be the least annoying bit to do that. I also do not push all the buttons on my own infrastructure, which keeps sysmerge happy, so when you're updating, it does not prompt you, hey, you need to merge this in, and hey, you have made that change. No, I don't want to do that. It should be automated. And I do run current on all my systems. Which means I get to fix or report all the things that currently annoy me or that are broken. Now this sounds a bit counterintuitive. My time has value, I don't want to spend a lot of time on this. Why would I do that? That sounds painful, right? Well, kind of not. For starters, someone has to do it. Otherwise, we can't actually cut a release to find, oh, we are stable enough now. However, current is not unstable. It is very stable. Everybody, all the developers run it. I run it on all my infrastructure. And I found over the decades, a huge time saver is when you're on releases. With OpenBSD, you update every 6 months. If you're on a Debian, maybe twice a decade, that kind of thing. You will find, you will find that suddenly everything is broken. There are major upgrades in packages. You have a new Postgres release. Your mail server changed the configuration file. Your monitoring is broken. So you're doing an upgrade and everything is just down. And you spend a week fixing things, which is particularly annoying if your monitoring is down because you don't know what's actually broken. So that's the first thing you're fixing, right? If you're running snapshots, if you're running current, it tends to that, well, usually nothing is broken, but if something is broken, it's usually one thing at a time. Like there's a major Postgres update. Okay, fine, I'm dealing with that. Takes me 5 minutes, 10 minutes, that kind of thing. A month later, there's a major upgrade on my monitoring, and okay, fine, I'm fixing that. If I'm on releases, oh, yes, I'm upgrading now. I'm going to spend a week on fixing things. I really don't want to. Let's do it the next week, and the next week. And that way you end up with systems that are like really dusty and 5 years old and nobody wants to touch them. That's not good for stability. So I think this is actually a time saver to do it that way. You also get to flex your sysadmin skills because once in a while you need to sysadmin some things, not once every 6 months. And you get to test your restore procedures if you really mess up. And well, you all have backups, right? And you know that they're working? Well, this is your chance to actually test that. And the last but not least is you have a realistic things to actually get your fix and use it. So if you're reporting a thing that's easily reproducible, we will have it fixed in no time. And this will be in current. And so you upgrade to the next snapshot and your fix is there. It's unlikely that it's going to be an errata for the stable release because erratas are really well, annoying to do and they're very time consuming. So of course if it's a security disaster, there will be an errata. If it's, oh, my screen flickers once a minute, that's not errata worthy. It's just too much effort. So if you're in current, you actually get these fixes. Now, I want to describe on how to run current the smart way. For that, I quickly need to go through the actual development timeline of an OpenBSD release. There are some things that are only internally visible, they're internally communicated, and the things that are publicly visible. So release cycle starts with the tree unlocking, and you can see this with a commit to newverse.sh, where we changed the name of the release from 7.7 to 7.7-current, which happened last April, I think. And then people can commit. But 7.7 release is not out yet. That comes out like maybe 1 or 2 weeks later. So so current is ahead of that release, but it comes out a bit earlier. So we're then hacking on that, and a bit later, like 3, 4, 5 months, the name changes again, where we increase the version number to 7.8-beta, which is what we're currently at. But that has no real internal consequences. We're only doing this for the port tree because there are weird packages that, or allegedly in the past, that check this version number. So we want to crank that to shake that out. We just continue hacking as normal, and at some point, the slowdown is called for internally, which means well, focus on fixing regressions, don't introduce new ones. Shortly after that, ABI log, no changes to public header files, that kind of things. At that point, the ports builder can start building the packages for the next release. Then the name changes again to 7.8. We drop the beta. But that does not mean this snapshot that comes out then is going to be released. There are multiple snapshots that actually are called 7.8. At some point we're locking the tree, so no new commits. Unless it's really catastrophic, then Theo can sneak some changes in still. And then we're back to the tree unlock where we started. And we do this every 6 months for the last, I don't know, 30 years or thereabouts. So running current the smart way. I would suggest to update once a week. The upshot there is you get all the library bumps. You have all the library versions on disk, and the packages will actually still work there. So we do a library bump, you have old packages. It just uses the old library. This works most of the time unless there is really a flag day. If you don't do that, then you might miss a certain library bump. Your packages don't match. You need to wait until the packages catch up. So that's annoying. When we're switching from release to current, you want to be a bit less aggressive there because new snapshots are coming out. Because all the build infrastructure is busy with building the actual release. So these changes then are not well tested. You can be more aggressive towards the end of the release cycle because then we're really slowing down and all the difficult things have been committed at that point. You also want to pay attention when there's a hackathon happening. You can see this with there are a bunch of commits coming in or a change to hackathons.html. So those changes tend not to be tested that well, but it would be appreciated if you have some infrastructure that's like redundant. You pick one and try these things out because the sooner you report a problem, the easier it is to fix this. And you really want to be subscribed to a bunch of mailing lists, and so you don't need to understand all what's going on there, but have an idea, oh, there are changes happening in this area. So say you're running a redundant firewall and you're suddenly seeing, there's a memory leak in PF and I'm running out of memory. Then you look, oh yeah, there were 4 commits to PF, it might be that, and to get an idea, and that's really helpful if you report that. Benno and me also have this archive website where we keep the last 100 snapshots or so. So if something is really catastrophically wrong, you can try to roll back, which usually works out. There's also running current the Florian way, which is known as the wrong way but faster. Basically, I'm just rebooting all my infrastructure and I'm keeping one name server alive. And I've been doing this for the last 3-4 years and it just works. It does. And this is the first spot where I want to talk about something that was annoying and we wanted to be easy. So I was talking about, oh, I'm rebooting all my infrastructure to reboot it, to upgrade it. So how does it actually work? Well, in the past we had this thing called BSD which is the installer, and we still have that around. That's the installer. And that thing also handles the upgrades. It's text-based. It asks you a bunch of questions. So that's not very automatable. Then about, I would say 10 years ago, 2014 time range, Uwe had a specific itch to scratch where I think he wanted to automatically install systems. So he came up with a framework for that, which is basically, so the installer asks you a bunch of questions. Well, how about you put the answers in a text file? And that's what that thing does. You provide the answer in a text file, and then the installer does an auto install. Well, it turns out that the upgrade process works the same way. It asks you a bunch of questions, so provide the answers. It does that thing. Now the problem is where do you actually put this answer file? And this auto install mechanism worked over TFTP, so you fetched your installer and you fetched the answer file. It copied this to the RAM disk and started from there. So you need a bunch of infrastructure for that. I have random VMs at hosters and some servers. I do not have a TFTP boot server. That's just not happening. So Semari later came up with a scheme where, well, the answer file is expected on the RAM disk. How about we just put it on there? So you're fetching your BSDRD, unpack it, mount the RAM disk file system, put the answer file on there, unmount it, rewrap it, and boot that thing. But it's still not automatable because you need to tell the bootloader, hey, please run BSDRD. So you reboot and you're at your bootloader and someone distracts you and it continues booting and you missed it. Okay, fine, I'm rebooting again. And then, okay, now you can run BSDRD. And it does your update. Now there's a hack that you can do. You can name your BSDRD just BSD. So your upgrader is suddenly BSD. You reboot and the bootloader picks it up and then your install kernel crashes and reboots. And then the bootloader picks up your install kernel and boots it, and it crashes and it reboots. So you're in a boot loop at that point, so that's annoying. So you need to go back to the console again. So we had this hackathon in Taiwan. I'm sitting at the same table as Theo, and we're talking about random things. And at some point, he brings up this EuroBSD thing from Saint-Marie and says, "I really despise that thing." Why? It kind of works. I'm using it all the time. It's great. Yeah, but it's a package. So why is our upgrade process depending on a package? This should be in base, and it should not be a hack. We are developing an operating system. We can change all the things. How about we change all the things? What do we need to do? And then, okay, we are brainstorming this. Okay, so you need a shell script to fetch the sets. It creates the answers, and it puts the upgrade kernel somewhere so that the bootloader can find this. So name this thing bsd.upgrade. Hack the bootloader that it sees there's bsd.upgrade. Oh, I forgot. So we put it as bsd.upgrade and we make it executable. So the bootloader sees there's bsd.upgrade, it's executable. It removes the executable flag and then it boots it. This prevents it from entering a boot loop, because so the bootloader has a very limited support for the fast file system access. It certainly can't write. It doesn't understand dirty file system. It can read from it, and it can change 1 byte, and that's enough to actually change this flag. And then you need a bit of magic in BSDRD for it to actually find the answer file. So the answer file was normally provided to it. Now it sits on the installed root disk, and it needs the answer file to find the root disk. So this is a chicken egg problem. So we have a heuristic to find that. We find the root disk, copy the answer file over, and then we enter this auto-install thing there at the top. So the point about all this is, this took us like a decade to arrive there. It's not, there is this magical inspiration and we do something great. It's, well, we had this thing, how can we build up on that and make it less annoying? And, well, oops. Another fun thing about sysupgrade is, it basically takes you 2 releases for the users to actually be able to test it. Because, also they're on releases, so they don't have it. So they need to install a release, then they get sysupgrade, but they're not using it. They're using it 6 months later to actually be able to use it to upgrade to the next release. So they're 2 releases away. Well, this is annoying. We are still in Taiwan, and I mentioned, hey, how about we errata this? And Theo looks at me like I had grown a second head or something, like he's really angry. Like, no, we're not doing this. Errata, I mean, I mentioned this, right? Erratas are annoying. And so I'm just sitting there, okay. And then it starts to sink in, and suddenly, so Theo's smile gets wider and wider. Yeah, this is properly insane, we're doing that. So yes, we got this errata out, and we skipped 1 release. I found this was really neat. And it can, so I was mentioning this archive, and you can use a sysupgrade to bisect problems. So you do a binary search over the snapshots that we have. Now, I've talked a lot about OpenBSD, and this is actually the slide that kind of like triggered this talk, where this is coming from. So as the saying goes, OpenBSD is a hiking club with a computer problem, and we have a very specific computer problem. And that computer problem might not be your problem, which is fine. We're doing that for us. We're a bunch of volunteers. We're doing this for the fun. And so the actual thing, what triggered this was someone in the community said, hey, can't the OpenBSD Foundation tell you what to do? No, it does not work like that. We're volunteers. We just work on what we want. And the worst thing, or the most force someone can exert on me is to say, you don't get to commit that. I can work on whatever I want. Maybe it's total crap and it's not getting committed, but you know, they can't tell me you're not working on that. And from a user's perspective, since we are doing this for fun, showing up on the mailing list, being grumpy and asking to speak to management and demanding a refund, that's not going to end well. So you're probably at that point speaking to a specific developer whom you're pissing off, but that person put time into to actually talk to you, so you're pissing them off. But the other developers are also paying attention to this. So I have a well-curated block list. If you don't want to be on that, thanks. So then, of course, the question always comes up, hey, I want to contribute. And the canonical answer for that is, well, run it in a report box, including documentation box. So if you can't understand the thing, that's probably a documentation bug. We are not assuming that you're dumb. It's something needs fixing at some point, right? And I would suggest to see Michael Dexter's talk. He was speaking yesterday about bug reporting and a bunch of other things. I've seen the recording from BSDCon and it was great. It's the answer to how to do proper bug reports. It's really good. But I want to contribute code. That's the next step. So the question then is, why do I actually want that? And for a bunch of people, it seems to be, oh, I need this on my CV and I want the commit bit. Okay. I really can't help you there. But you have a list of to-do items, surely, right? You're completely overworked, you have this pile of to-do items. Yes, I do, but those are my to-do items. I'm doing this for fun. Like, does this spark joy? This does not spark joy. What am I going to, what? So this is my to-do list. If I'm taking an item off and hand it to you, then I need to explain this to you. This does not spark joy. So I want to keep this to myself. If I'm taking something off my to-do list that really does not spark joy and hand it to you, does it spark joy for you? No. You're going to hate this, and maybe you feel obliged to work on this, and this is not going anywhere. So if you really want to contribute, find something that annoys you, but not so much that it does not spark joy. Like, oh, I want to fix this. This is really annoying, and it would be great if it was fixed. So work on that, and submit a patch, and prepare to iterate on that patch. The best thing that can happen to you is that the developer shows up and tells you, okay, the following things need to be fixed, and that's really a great thing, because that means someone actually spent time to read your diff and decide, yes, this is worthwhile to work on, and they're taking the time for you to learn something. Don't take that personally. Oh, they're telling me I'm not good. No, that's not what this is about. So, in practical terms, this is my origin story. I was at this ISP about 15 years ago. We were rolling out IPv6 everywhere, and of course, IPv6 support was terrible everywhere, not just in OpenBSD, but I fixed all the things. I fixed monitoring, I did this and that, and well, we were running a pflow to get NetFlow data out of our firewalls. Of course, that thing did not support IPv6, so I started hacking on that. And so I was working on the kernel part. Benno was working on the user land part and communicating to the kernel. And this thing got a bit biggish. So that's the other thing. If you're submitting a thing, if it's huge, a 10,000 line that replaces UVM, well, don't do that. Some of us are successful with that, but probably not you, so no. So it should be reviewable, and so this one I think was right at the edge. And I think why this also worked is it did not introduce something completely new, it added to something that was already there. So you could see the flow of the logic. It followed the same logic as what was already there. So eventually we got this in. Benno got an account, I got an account, so everybody was happy. Yes. I don't think this time is actually right. Well, never mind. Another thing where we wanted something to be easy, and that's Pledge. I think this is another great example where it did not just fall from the sky. This was based on other things. And this other thing was systrace, which we used in base, and that was the only program that actually could use it in base was SSHD. It was that difficult to use, and so what it did is it had an external configuration file where you list all the syscalls that this program is allowed to do, and which arguments it gets. And that's kind of like what SecComp BPF is also trying to do, is at least that's my understanding. And a mere mortal can't work like that. That's like not if you're working in userland, not if you're working on programs. That's really kernel level abstraction, and that doesn't work well. So yeah, we looked at that, or well, Theo came up with this, and I think one of the great insights from that was when a program initializes, it needs more permissions than when it actually runs, and this is what Pledge did. So the actual configuration is inside of the program. You put it after the initialization. The other innovation there was that it did not bother with the syscalls, but it did categories of syscalls. I'm allowed to access the network. I'm allowed to read from disk. I'm allowed to write from disk. I'm only allowed to access already open file descriptors. And it turns out this was really fun to use. People got really excited about this. Where it was kind of like a competition. Oh, I want to put pledge into this program, and so then you had that, and then you were thinking, can I make this tighter? Can I remove some permissions? And you looked into that specific program and saying, yes, I actually can. The problem is that a part of the initialization is down here, so I'm pulling this up, and I can make this pledge much tighter. And a bunch of people jumped on this, and we basically had a more or less full adoption within one release cycle. So there are things that are fundamentally not pledgeable, or it does not make any sense. They're just using one obscure feature of the kernel. That does not actually help you anything. And the last thing I wanted to talk about is also a thing I was involved in. Is I was working on this recently. This is for DHCP v6 prefix delegation. So I had a need for this in my own network. Eventually I got around to work on this, and I did not just start from scratch. So I used an existing daemon, which is the DHCP CD. And I looked at the configuration, and I kind of came up with this. It worked, but I could not understand why it works. So it requests a prefix delegation, number 2. I have no idea what number 2 does. Okay. /59. I know IPv6. It requests a /59 prefix. Okay, great. V is a 0. Okay, that's a network interface. /0. Well, it's probably prefix, like index at 0. It's prefix 1 that it uses there. Configures a /60 on there. Okay, fine. V is a 1 /16. Where's that 16 coming from? It doesn't make any sense. So I had a 1 there first, and it did not work. That's something insane. So eventually what I did, I started then to read the RFC. I started to read the code. The documentation did not quite explain this. And eventually it dawned on me what's actually happening there. You need to do you need to split your prefixes yourself, and you need to do the math yourself. So you need to do a net plan. What that 16 means there is, give me the 16th /64 out of the 59 prefix delegate. So why that? Well, it turns out there are 16 prefixes in a /60. So it's not telling you, you're not telling it, give me the next free prefix. You're telling it, well, I carved out this bit, and then you need to tell it to jump ahead, and this is the next free thing. And that broke my mind. I was staring at this, okay. I mentioned that the documentation is not entirely clear about this, and I'm figuring, okay, you can't actually document this. I mean, you can document this for a network admin, which I also tend to be, so I can actually understand this, but a mere mortal can't understand this. And so I put a lot of thought in how to actually improve on that, and I came up with that configuration, where the daemon does the math for you. So you don't need to tell it, I want a 59, and you just tell it, oh, give me that prefix and then give me the next free one, that kind of thing. So I'm not telling that, I'm not trying to say that, oh, DHCP CD is terrible and they did a terrible job. No. They were there first. And it's a great program. It does all the things. It does v4 configuration, v6, Slack, it does all the things. They just ended up with this configuration. And I very strongly suspect that they're stuck with this configuration because it's just deployed, so they can't change this anymore. But that doesn't mean that we can't change it. So this thing had to be there first for me to actually understand this is the problem space. If it had not been there, I probably had come up with something like that without even realizing, yeah, you probably should not do that because nobody's going to understand that. And, well, nobody interrupted me with questions, but maybe you have questions now. questions? Okay. Well, thank you.
Works, right? Perfect. Okay, I guess the clock started, so I'll start. Maybe I stand back a bit to avoid the echo. Thank you for coming. I'm more or less the user follow-up of the last talk that happened in here. So if you happen to be in here, there will even be some slides that are quite similar. Generally, what I'm going to talk about is, well, just an outline here, a short intro with a short intro about IPv6. It's very short, so and then I'll introduce my setup, what I work with, and then I'll tell you about the challenge, which is in the title, obviously, and then where my challenge failed, and then what happened in the end, where the previous talker actually saved me. So, about me. Usually I work with Linux and basically I've got no clue what I'm talking about. I use OpenBSD privately a little bit, FreeBSD a little bit more, but the reason why I'm giving this talk is basically below there. I first tried OpenBSD in somewhere around 2005, 2010. I installed it on a laptop. And coming from Linux, how I approached this, I tried to configure this. I went to the internet, searched whatever search engine I used back at this time, and could never find anything about OpenBSD. Like, how do people even use this? There is nothing on the internet. It basically doesn't exist. And then I went on a holiday. It wasn't on a deserted island. It was in South Tyrol, in the mountains. No internet back then, no Wi-Fi. And I took this OpenBSD laptop with me. I was sitting in a hotel, had no clue what to do. So, well, just throw this machine on and see what I can do. And of course, I didn't have internet, so I just opened man pages. Well, like, if you're used to Linux man pages, like, they're short. There is some information, but it was like OpenBSD man page. There is everything you need. I mean, basically you can configure this system just using man pages. So that's basically what led to my challenge. A year ago, I had to learn about IPv6. I had to learn about IPv6 only networks because we want to have IPv6 only clients at work in a new network we're deploying right now. So I needed to figure out how this works, and of course, how do you figure something out? You just set it up yourself. And because I knew the documentation was great, I was saying, well, I'll just do this as a challenge. I have my box, I have my serial connection into this box, but nothing else. No internet, I'll just go with man pages, with whatever I find on the base install. Of course, I do the base install with internet, downloading it from the internet, but from there, it's just the base install, and I go from there. So this is my short IPv6 introduction. I put the IPv4 on this side, IPv6 on this side. Of course, you have more bits for the address. You had 32 bits before, now we have 128. You don't see all the 128 bits because you can omit zeros with 2 colons, as you see there. Usually, a network in IPv6 is /64, so you don't have this, you have /20 networks, /24 networks, / even smaller, because it's only a linked network, you only need 2 addresses. So you just use /64, and the first 64 bits are the network prefix, and the second 64 bits are the interface identifier that the machine can either make up, you can configure it statically, and so on. So in IPv4, we had DHCP v4 to configure systems automatically. In IPv6, we have stateless auto-configuration of addresses. Basically, just means make those 64 bits up yourself according to a certain mechanism. And yeah, sadly, eventually someone added DHCP v6 because it turned out people want to manage IP addresses centrally. Some things you can't do with flag. You can't hand out like NTP servers, for example. So we have both in IPv6. But you can, I didn't use IPv6 for my setup. Well, it's there, but you'll see. We had ARP in IPv4. Now we have neighbor discovery. The big difference is neighbor discovery is an IP-based protocol. It's based on ICMP-v6. So if you come from IPv4 and you say, well, ARP is evil, we have to disable ARP, we have to block ARP everywhere, IPv6 won't work for you. So it's actually going to break. We had network address translation, the famous security mechanism, which of course is only there because we don't have a large enough address space. It's not meant, it was never meant as a security mechanism. And in IPv6, people, I think they tried to get rid of NAT, but of course we need NAT if we want to have those transitions. If I'm in an IPv6 only network and I want to talk to the internet, I need somehow to transition from IPv6 to IPv4. And if you have a IPv4 only machine, I don't know why you would, but if you do, then if someone from IPv6 wants to your machine, you can announce an IPv6 address and NAT it back to 4. So that's why you have NATwise. Yeah, eventually someone added also NAT66 for some reason, because people apparently like NAT and they also want to NAT from 6 to 6. So the NAT64 is basically the most important mechanism I use. So I'll give you a short introduction to DNS64 and NAT64. This is when I ask my resolver, what's the address of SDF.org? You know SDF.org, there's the BBS from 1987. They run, I think, NetBSD. And of course, they run a lot of like retro hardware and everything, but they don't do IPv6 because, I mean, IPv6 came along in 1998, they're from 87. So what I get for my resolver is this. And that's basically a special prefix. It's a made-up address. It's a special prefix we use if we want to connect from IPv6 to IPv4. So what happens in the background is the A record looks like this, and I just take the special prefix and then attach the IPv4 address to the last 32 bits of the IPv6 address become my IPv4 address. By the way, I didn't make this up. This is a legal way to write IPv6 addresses. It's not just an invention I did. This I don't remember the RFC, but you can do this. Then, of course, if you convert this to hexadecimal, you get this address. And that's the address I use to connect to SDF because I don't have, most of my systems don't have IPv4. So, my setup. I've got an ISP. My ISP is quite generous. I get for a home ISP, not otherwise, but for a home ISP, it's quite generous. I get a static /48. That's not the one I get. That's the one that's in RFC 3849. It's meant for documentation purposes, so I'm going to use this one. And I've got a PC Engines APU, those small machines. They don't make them anymore. It was running OpenBSD 7.5 back when I did this. And I have a VDSL bridge just to bridge to Ethernet, so it doesn't do anything. I basically do everything on the OpenBSD machine. And to give you an idea how professional this talk will be, I also included a picture of my perfectly clean 19-inch rack, which looks like this. You see the OpenBSD box on top there. At the bottom there is the Zyxel bridge. There is also a RIPE probe here, and there is the old Fritz box I used before. It's only used as a DECT base station now, and there is the FreeBSD server, which is powered down because there are a lot of projects I want to do, but apparently I have too much hobbies that are not IT. So within my OpenBSD box, it looks like this. I've got 3 physical interfaces. I use, well, basically 4. One is a Wi-Fi interface. I use 3 of them on the inside. One is unused, but for another network, if eventually I want to use one. and I use one on the outside to talk to the VDSL bridge. I have two networks. I've got an IPv6 only Wi-Fi, and I've got a dual stack. Well, it's Wi-Fi and wired because I have devices, like currently still my work laptop, because 40 VPN apparently still can't handle 40 VPN still. We can't manage to get 40 VPN to work in an IPv6 only environment. And service-wise, we have the router advertisement team. The router advertisement team does what it says. It sends out router advertisements, just telling my system's here. I'm here, and that's my prefix. That's the prefix you can use for Slack. And it also hands out the DNS servers or DNS resolvers to use. I use the DHCPD just for the dual stack part. I'll tell you more about the option 108 later. I use packet filter as a NAT64 mechanism. I use unbound as DNS resolver. I just heard in the last talk, maybe I could also use unwind, but I can't. Okay, thank you for shaking your head. So I'm right, because you remember I did this without looking anything up on the internet. So unbound is just what I knew. I found it on the system, so that's what I configured. And I used at the beginning DHCP CD as DHCPv6 client, but more to this later why I use this. It's now not part of the setup anymore. So if I hook up my client to the network, that's what happens. First, it sends out the router solicitation, then it gets back a router advertisement from my OpenBSD box telling it, well, that's your DNS resolver, that's your prefix to use, and please make up an IPv6 address. And then I've got the DHCP4 server. I can send a request to the DHCP4 server with this option 108. This option 108 is basically called IPv6 mostly. So that's a way for me to indicate as a machine, I'm fully IPv6 capable. If you have a network with the transition mechanisms like NAT64 and DNS64, I don't need an IPv6 address. And then the DHCP server can send this option 108 back, telling me, yeah, my network is fine, you're fine, you don't have to get your address, and it sends back 000, or it can send back any other address that's not used. And I'm not going to bind this address. I just throw it away because I know everything works. Then I've got name resolution. You saw before what it does. It also does the DNS64 part. And then if I talk to the internet, either I've got someone who's IPv6 capable, then it goes just through directly, or I have to do this network address translation from 6 to 4. To talk to the internet. And on this side, basically, I can attach a client that's IPv6 only, if I want to. Or on the Wi-Fi, I even have to. Okay, so this is going to be a challenge. So this basically, for every part, I will tell you where I found the information I needed, and then I'll tell you what configuration I did with the information I found. When you first install an OpenBSD system, of course, then I didn't have the internet, so what do? It's very easy. Every base install comes with an email. The email has a lot of information about how to get started in OpenBSD. You just enter mail, and then it also tells you, yeah, there is this manual page. It's called After Boot, and tells you again a lot of things, how you configure your system, basically. There is also the help command, even including more information. So it's like booting an OpenBSD system the first time is a bit like reading a book. So you just read through those pages, and they're quite long and very informative. And then from there, you also know how to configure a network. You already know there is the hostname.if manual page, there is the ipconfig manual page, the net start you use to restart or reconfigured the network interfaces. And from the ipconfig, manual page, I also know there is a PPP over Ethernet manual page. I need to talk to my ISP. So basically, this gave me all the information I needed for the network configuration. And that's basically what I did. I first created the PPP over Ethernet interface. You, of course, have to set the physical interface under the PPP over Ethernet. You have to set this to up, but you don't configure it because you only use it to transport the PPP over Ethernet connection. And then you reconfigure the network. That's what my PPP over Ethernet config looks like. Also here you find a perfect sample on the manual page, so you don't have to do this yourself. Apparently the manual page told me those IP addresses 000 and 000.1 are just placeholders. It will be replaced later by the IP addresses you get from your ISP. And I did configure down here, I did configure IPv6 to do semantically opaque interface identifiers. This means you do not include, some time back, people still claim IPv6 is not safe because you have the MAC address in your IP address, which used to be a mechanism that you can use. You shouldn't use this anymore. This is just, you select the bits, the 64 bits randomly, and if you change the interface, you select another 64 bits. But as long as you use the same interface, you get the same address. But it's a default, but I like explicit config, because then I know what I'm using. And then I just inject some roots, which is just a default root. It's not very interesting. That's for the Wi-Fi. Again, the config. That's the prefix I get from my ISP, right? And then I just have to make up a network. And of course, one of the huge advantages of IPv6 is you can have fun making up IP addresses and networks, right? You can have words like cafe in your IP address, or beef if you're not vegetarian, something like this. And I also, for the PF configuration, I also add this to a group that I can group all the inside interfaces together. By the way, I will tell you later in the talk why this configuration doesn't work, but I thought, at this time, I thought it will work. Same here, another configuration, which actually, I should have quit my email client. Another configuration that doesn't work, but again, the same reason. Here I just chose another word that works with IPv6 as a second network. This is the network that also has IPv4. And of course, with IPv4, the only fun part you can do is put 42 into IP addresses. So that's why I put 42 in there, also added to the group inside. I also configured the loopback interface, which might not make sense at first, but the reason for this is I wanted to have explicit DNS resolver IP addresses for in case I decide I need separate DNS resolvers. I don't have to change the address then. So I just bind two addresses as aliases to the loopback interface in case if I have resolvers. Otherwise, I just move them to the new resolvers. So those are the IP addresses Unbound will bind to. Okay, then packet filter or NAT64. I used, of course, you have to look up the pf.conf configuration page, our manual page. But then I also need, I have to enable certain ICMPv6 types, and I want to disable others. I want to be able to speak to the internet over IPv6, so I need a lot of ICMPv6 because router, neighbor discovery is based on this. But I also want to disable, for example, for the internet to be able to ping every device and my heater and my coffee machine, everything at my home. I mean, you might want to do that for debugging in a corporate environment, but I don't want to have this at home. So that's basically this manual page lists all the different ICMPv6 types you can have. That's my default config. Basically, I just put configuration on the outside interface and filter inside. And everything else I just let through. I'll let everything that wants to leave the OpenBSD box, I'll let everything out, no matter where, because I don't want my internet to be like the internet here, where you have to open SSH and all the other ports still don't work. And I think XMPP on my phone currently doesn't work because they blocked the port here. So at home, I just let everything out and just filter on the inside. By the way, that's firewalls. That's the real security mechanism, not network address translation. So that's the important part to configure if you have IPv6, because you're using public addresses inside, right? So you want to pay attention what you configure on your firewall. Those are the ICMPv6 types I need: router advertisement and router solicitation, because I have to discover the router from my ISP. And of course, I need neighbor discovery, so I need neighbor solicitation and neighbor advertisement. I want to know when something is unreachable, so I want to get this message back. Another fun way to break IPv6 is you block the too big ICMPv6 type, because we don't fragment with IPv6, right? And if you get at some point to a point where the MTU is too low and your package doesn't get through, it will send back a package too big ICMPv6 message. And if you block this message, you will never know that you have to resize your packages. It just won't work. Yeah, time expired, and parameter problem is basically an IPv6 header problem. So those are just the usual error messages. Time expired is if the time to live of a package reaches 0, that's what you get back. And that's now the actual NAT64 rule. Here you see again this well-known prefix, the 64FF9B. I put in front of my IPv4 addresses. I said we don't use anything else than /64s in IPv6, but here, of course, I use a /69 because I only need 32 bits to embed the IPv4 address. And then I NAT to this is just the first IPv4 address of the egress interface, which is obviously I think it is. It's obviously just that there's just one address, the one I get from my ISP, which is generous. My ISP is still generous enough to give me a public IPv4 address. So then I need, in my network, I need to be able to tell my systems where my router is. So I need to send out router advertisements. That's another very, very nice folder you find in OpenBSD systems, the etc examples folder. There are plenty of examples you can just copy over to the /etc and start editing. And of course, there is again the file formats manual with a lot of information how to configure router advertisements. So that's what I ended up with. I hand out my DNS server, of course, only the IPv6 address, not the IPv4 address. That's the one that's bound to the loopback interface. I tell it I want to send out router advertisement on the two inside interfaces. And then maybe you wonder, maybe you don't, why do router advertisements need the IPv, the well-known NAT64 prefix? Because they don't do anything with it, right? It's just DNS needs to know it, and packet filter needs to know it to translate to IPv4. So the reason why it's there is you can, over router advertisements, you can tell a client the NAT64 prefix. It's called pref64, the mechanism. And the reason why you want to do this is you have this mechanism called CLAT, which is the client address translation from IPv4 to IPv6. So if you have a Mac or an iPhone or an Android device, and you try to ping, let's say 9999 on your device, DNS64 doesn't help you because 9999 is an IPv4 address. So what your device has to do is it has to translate the 9999 to one of those synthesized addresses. And it can only do this if you tell it what the prefix is. So basically, it's called, this mechanism is called 464 XLAT, because you translate, on your device, you translate from IPv4 to IPv6, and then on the router, when it leaves the internet, you translate this back to IPv4. Sadly, Microsoft said they will implement this in November last year, but they didn't say when, so maybe it's like in 10 years. So that's one of the problems we have currently with Microsoft or with Windows clients. If you have a software that relies on IPv4 addresses, like those old software, you have 4 boxes to configure your server, and you have to enter the 4 8-bit values for the IPv4 address. Those things won't work in our environment on Windows. It will work on Android, iOS. You can configure Linux to do this. Maybe someone tells me whether, I guess you can use the same mechanism on the BSDs, but maybe you can tell me. I don't have a BSD client anymore. Yeah, so that's it. And then we configured the DHCPD for the IPv6 mostly part. So if a device wants to have an IPv4 address, you can still hand one out. I needed to look up the DHCP options man page because I wanted to know what the option 108 is called in OpenBSD. I mean, you have to, I think you can configure the number, but of course it's nicer to have like sensible names in your configuration. So that's what I got there. Of course, I hand out the name servers, I hand out the router, I define a range, all pretty straightforward. And then the important part is here. That's the option 108. So if a client tells me it's fully IPv6 capable, I just don't hand out an address, and I tell the client, you don't have to check for another 2 hours. Why did I put 2 hours here? The option was mentioned on the manual page of OpenBSD, but the unit wasn't there, so I didn't know what to put there. And I thought, well, maybe it's hours, or maybe it's seconds. So I just put this here, and later I realized I put, maybe I even copied the value from somewhere. I'm not even sure. But later I found out I configured this to be 2 hours, which might be a bit too low because I'm not going to change this. So maybe I should open a documentation bug for this, according to the last talk, until well, then we have to get the unit there. That's maybe, yeah. I'll add this to my to-do list. Then I configured the DNS resolver to do the DNS64 and just to generally resolve names in my local network. By the way, that's also important. Maybe not, well, maybe it's obvious, but you have to force people to use your resolver. If you are in your local network and you depend on this DNS64 mechanism, and people just start configuring, well, DNS, yeah, it's 9999 and 8888, it's not going to work. You will be able to talk to IPv6 endpoints, but you won't be able to talk to IPv4 endpoints. So that's the config there. Still, time's still looking good. What I discovered, but this wasn't on OpenBSD, I discovered this before because I also run Unbound on Linux. It's important in what order you specify the module config. DNS64 has to be the first option, otherwise it just won't do DNS64. I haven't fully understood why this is. So if someone can tell me, maybe tell me later. Those are, again, those addresses. I tell it to do IPv6. I also tell it to prefer IPv6. Means towards the internet for name resolution. Of course, every device decides itself what protocol it's going to use, but just for resolution towards the internet, I prefer IPv6. And then there is, again, the prefix. It's a default. You don't have to configure this, but again, I like explicit configuration because then you can just tell what's going on here. You could leave the last line, you could just grab it. And below there is some more configuration, like security configuration, who is allowed to use the resolvers and so on, but that's not important for it. This configuration should work right here. Yeah, and then we're done, right? Still, no traffic. So something is not right here. And no manual page told me what wasn't right. I then took my laptop, went on the internet, did some research, and eventually realized, well, yeah, my ISP is generous. I get a /48 prefix, and it's fixed, it's mine. It's even on a piece of paper I got from my ISP. But my ISP won't route this prefix to my end unless, the failure, yeah. Unless I get the prefix from my ISP using DHCPv6 prefix delegation. And then I realized, well, the system doesn't have a DHCPv6 client. It was OpenBSD 7.5, right? So I went on the internet, researched, found out I have to configure DHCP-CD. I allowed DHCPv6 on the firewall. Those are link local addresses because you generally talk to your router via, or at least that's the way my ISP configured this. You talk to the router via link local addresses. Everything that's FE8 is a link local address in IPv6. And then I configured the DHCP-CD. If you have been here in the last talk, you will understand those weird numbers I put here because they were explained in the last talk. They're a bit higher than in the last talk. Where do they come from? It's weird. The last talk that he mentioned, it's the 51,966 network in this prefix. And the 49,3,700, never mind, you can read the numbers yourself. Where does this come from? Well, it's the first one is cafe in hexadecimal, the second one is code in hexadecimal. So again, my fun with IP addresses. And that's where my configuration at the beginning didn't work. I can't configure the IPv6 network in the hostname.if file. I have to use the DHCPv6 client to then get the prefix delegation and then assign a network to the interface. That's basically what I'm doing here, right? I tell it use this network on the interface RE2 and make it a /64. Here I tell it get a /48 from my ISP and then use one of the 64-bit /64 networks on this interface and use the other on this interface. And then I have the same configuration as before. Thank you. I have the code network and the cafe network. Okay? And now I had internet connection, I had IPv6 traffic, I have had translation mechanism, everything worked, so I'm done now, right? No, you're not done, of course. When you achieve something, then you go to the Fediverse, you post about it. I've done this, and yeah, that's my Fediverse post about this. Then someone came along and told me, well, if you run OpenBSD 7.6, if this guy is here, or if someone knows him, just tell him hello and thank you. If you're using OpenBSD 7.6, then there is this awesome tool, DHCP6 leasd, which is in the base install, so you don't have to install any packages. You can just use this tool. So I just ran sysupgrade, upgraded my system, and went on to configure this. And now, I promised this to the previous speaker, that I tell him what I didn't like about his tool. What it does is, I can reserve a network, so the first network, the 0 network, I'll reserve this, and then the first network is used on the RE2 interface, the second network is used on the Wi-Fi network, and I get the /64 in both, but it just uses the first and the second. I want code and I want cafe, right? I want to have fun with those addresses. So the only way to do this is to put like 47,000 reserves in front of this to get the code, because then you reserve or yeah, maybe.
Reserve something longer.
You can reserve something longer?
Yeah, sure. You can reserve /56. But you have to mark it. Like
Okay, you reserve a /64, but then you have to still add more reserves to it, correct? Yeah. I mean, I can live with this. I don't have to have fun with IPv6 addresses. Yeah, and then I was done. So I have more time than I expected, so I even have time for questions. The QR code leads to my slides on my website. There is the email, there is the link, which is in the QR code, and there is my Fediverse, the one you saw before. It's running on Hubzilla, and because I have been on the Fediverse before it was called Fediverse, when it was Identica, I used to microblog there, and I still miss the microblog, so that's why I also run a snack instance, so that's my snack channel down there. Yeah, that's pretty much it. So there is another 6 minutes and 47 seconds for questions, if you happen to have any.
Thanks for the talk, it was interesting. Florian already pointed out that you can just reserve more space, but if your ISP gives you a /48, you can reserve a /48. You don't need to use DHCP C6 please D to configure those prefixes on your interface. You can just statically configure them.
Oh, I statically configure them in the hostname.if file.
Yes.
And just get the prefix
yes.
from.
If your ISP will always give you the same prefix,
yeah, it does. Yeah.
Then this will work. But you need to be careful using this as advice for other people, because some ISPs, of course, don't, and then you need.
Yeah, I selected my ISP to do so. So and this was.
No, I did the same, but it doesn't work for everybody.
Okay, I'll give it definitely a try. That's exactly why I gave this talk. I needed people to improve my configuration. That's great. Thank you. No more improvements, rotten tomatoes, rotten eggs, anything. Okay, thank you.
We're not going to really be talking about any of that today. Obviously, you've seen the topic, DJ BSD with MIDI stuff. So I've got my MIDI DJ controller. You know, I've actually used it quite a bit in my home setup, and sometimes when I have to do, like, you know, smaller setups, you know, out in the field, you know, it's very convenient. I can actually also use my phone with it, but we're not necessarily going to be talking about that too much because this is a BSD conference. And speaking of which, yeah, this is the session right after lunch, so I guess it's also my job to wake everyone up. Hence why we have a picture of a more than $2,000 setup that I played on, a little you know, local party back in Philadelphia. Yeah, even at about maybe 25%, 30% volume, you're going to need some ear protection for that. So, yeah, we'll get back to this picture in a moment, but I would like to make a little public service announcement for those who are watching on the stream or watching back on YouTube or video recording, because there were some comments from the previous time I did this topic back at BSDCon 2024. Yeah, 2024. There were a couple of comments on the video from other DJs or musicians, or supposed DJs or musicians, saying that they were complaining that I didn't cover enough of the actual DJing and features of the software and all that stuff. Well, first of all, or foremost, that's not the point of this topic. We are here at an operating system conference. We're talking about operating, like how all this stuff can even work on our favorite operating system family, which is the BSDs. So yeah, this is not a DJ tutorial. It's not really a tutorial on even making electronic music. This is, again, it's the whole operating system, how the stuff works in the background. And to really illustrate that point, I have a little clip from my favorite American football team, his head coach, when he was asked about a play that we do very well, but the rest of the league hates, that they want banned. But this is what the coach had to say about that. This was, I think, 2 years ago. So yeah, so that's the public service announcement for those who are watching on video. Yeah, that's not the point of the talk. So I'd also like to share this picture. So this was from the end of the Kitchener-Waterloo hackathon, just after BSDCon this year. It just so happened that at the end of the hackathon, there happened to be an open decks, which is basically like an open mic, but for DJs who want to have some fun. And it just so happened to be in Waterloo that it was just that Thursday night that they were having it. So I managed to drag, I guess, most of the people who were at the hackathon to the arcade bar that it was at, and also happened to be FreeBSD's birthday that day. So of course we had to. I mean, so they had another piece of equipment, another piece of DJ equipment that's actually a lot more, I guess, club standard, if you want to call it that. But because it was FreeBSD's birthday, and that this stuff actually works on it, we kind of have to flex the FreeBSD capability. So I ended up using this, even though I totally could have used that other piece of equipment, which I will show you in a little bit, where you just plug a USB stick in and everything loads and all that. It's a lot more suited when you have a more substantial sound system like this. So that piece of equipment in the back, that is a Pioneer DJ XDJ XZ. It's an all-in-one system. So pretty much you plug your USB stick, all your stuff loads up, and you select your track directly on the screen. So it has its own, I guess, real-time operating system in it. But it also has a MIDI capability, which that's really what we're going to be mentioning for the rest of it. But yeah, but most importantly, that has enough, that will output, enough, voltage and current to properly drive a sound system like this. If I mean, I totally could plug my RCA output from the controller into one of the inputs of that sound system, but it just wouldn't sound right. It just wouldn't sound as powerful as it should be. So that's why when you're at a proper setup, not only will you have something like, so you could do it directly out of that all-in-one, but the best way is to also have a separate mixer board like this, but obviously a lot more beefy of a mixer board like this, and then you plug that into the sound system. So yeah, so that's that. Yeah, MIDI stuff. So we have, like I said, I brought my MIDI controller here, but it's not just for DJing. Even though the form factor looks like you got a couple of jog wheels and knobs and faders and whatnot, but there's a lot more possibilities that you could do with MIDI, whether it's a controller or an all-in-one, or in this case, just a standalone CDJ. You could also do something like this. Just go back to the beginning here.
All right, I've tightened this up a considerable amount. So now we have our lock, so we can just get on target no matter where we're at. So I don't have to really worry too much about the camera position, which is pretty cool. Got my quick hit, big heavy hit, jump, and then use the stretch pad to roll. And if you hold jump and roll, and you do those like big ass roll attacks. So I think with some practice, I might be able to do this. I've installed a mod on here called Boss Arena or something. I don't know, it's just like one of those cheesy shit mod loaders. But it lets you just pick bosses and fight them, and I can make a build and stuff. So drop a build in the comments, and we'll fire them out. There's no way I'm doing this like level 0 reg. It's just not gonna happen.
Yeah, so that was deadmau5, rather famous electronic producer DJ. He was just messing around with his one of his. I'm assuming he has more of these CDJ 3000s lying around, but yeah, he's just using this as a game controller, and that's all made possible because MIDI doesn't really discriminate between what your use cases are. Like, sure, its original use cases have to deal with music and whatnot, or putting percussion sequences together at the very least. But in this case, he's able to he may or may not have programmed it himself, but he was able to get whether it was MIDI output or HID output, from that CDJ 3000 and turn it into game controls. So you can do a lot with MIDI. And actually, we'll go over to one of the documentations. So that's a CDJ 3000 that was in that example. So Pioneer DJ, or Alpha Theta as they want to call themselves now. But really any piece of DJ equipment, really any electronic music equipment, if they really wanted to have the widest use of their stuff and the widest range of software, whether it's proprietary or open source, they'd be well served to release some documentation with regards to all the MIDI messages that they output and support, or the HID specification. I don't think I've really seen many such cases of the HID documentation out there, but whatever. So yeah, this is standalone player. So in a typical setup, you would have at least 2 of these. I have to say at least 2 of these because there are examples of people using 4, 6, and 8 of these at a time with 1 or 2 mixers. But yeah, this is essentially the digital version of a standalone actual turntable, where you would put a record on. But in this case, Traditionally, these had CD drives in it, which is why they call them a CDJ. But mostly these days, you plug a USB, in that slot. And actually, more recently, you can also put SD cards because SD cards are a little bit smaller. They're a little bit harder to, steal, but to each their own. So these are just the reference diagrams of, each individual control that could output a MIDI sequence or a MIDI message. So here's some more screenshots of, what just general uses. But so as you can see here, so these numbers refer to part numbers. So this play pause button is number 7, this cue button is number 8, the pitch fader number 3, jog wheel, you've got 1, 27, and 5. So as we can see here, so the jog wheel especially, you can touch it, but there's also 2 ways of touching it. Well, so there's like a simple touch, and then it'll output, so it'll MIDI it'll send this signal here, and then there's some other details, linear value corresponding to whatever, and then if you spin the inner portion of the jog wheel, that's analog to you actually touching a physical record, like physically stopping it and like actually moving the entire thing with your hand. So when you actually play the sound, it sounds a little bit, so in fact, I can do an example here. So let's say, so I do have a track loaded here. So if I touch the inner part, I'm directly manipulating the scratch. Just do that. So that's the inner part. There's also the outer part of the jog wheel, which is more for when you're playing it, when you're playing the track, for instance, like this. So when I'm playing it, if I go on this outer part of this jog wheel, that's analog to when you're on an actual turntable, you can nudge the track, forwards or backwards to speed it up temporarily or slow it down temporarily. So right now, I'm going to try to slow this thing down. It's still going forward. The track's still going forward, but because I'm doing this, I'm slowing the track down. Now, if I go the other way, I can speed it up. So those are all effectively different MIDI messages. So but this is the CDJ documentation. I'll go over to my controller, which is this is my controller here. This is what I have. So this is just a straight up USB connection. So when you plug it into any of the BSDs, it will show up as Alpha Theta DDJ Flex 4 as a USB class compliant sound interface. So actually, when I was playing those other videos, I actually had the output directed directly out of here, which is why you were able to come out of here. But this also contains a MIDI sequencer, and you access that via some kind of software. So thanks to so Christos is in here somewhere. Thanks to Christos, but also really the wider scheme of or the demise rather of actual hardware MIDI interfaces. We no longer have the hardware bit because everyone just uses, or most everyone just uses accesses the MIDI sequencer via software. In my case, I'm using Sound.io. So if anyone here is OpenBSD person, thank you very much. So we actually, in FreeBSD, we also have so also rest in peace, Hans Petter Salaski. He developed the ALSA sequencer server, actually just based on the ALSA API. That was actually the first option I tried using Mix, which is the DJ software that I'll also pull up here in a moment. But every time I tried to connect to it on Mix, it would crash. The program would just crash. And when I switched over to Sound.io, it stopped crashing and it actually started working. So we're using Sound.io for this one. But back to this documentation, yes, it's pretty much, it's very similar. You have all these part numbers labeled. Play, pause button, cue button, jog wheel, You know, this is your loop in, loop out. Let's see, there's your pitch fader. You have all your volume faders. Is your crossfader. You got your filters here. You have your Q buttons. You've got your bass, mid, and high filters here. And then you have trim. This is like a menu selector. So back on the CDJ or an all-in-one, where you only have a screen, you would actually use that to kind of go through every menu, and you can press and load things. 2 separate load buttons. So pretty much everything here, even though most of these look like physical, physical controls, like the pitch fader or the crossfader or any of those for that matter, these are all MIDI. So if I did not have this, connected to an appropriate, software that would support MIDI messages, it would not be even functional at all. Like, I think the only actual, from what I could tell, even though it's listed as a part number that probably has its own MIDI control, I think it's 3-1 here. Yeah, the master level. What I found is that this master level is actually a physical, is pretty physical, but pretty much all the other ones, see jog dial, so the platter or the wheel side, they're all MIDI messages. And so we'll actually open up a program that I use for producing music. You can in fact use it, because even though the mappings are kind of all over the place for that program, for that program you would want something that has a lot more pads on it, probably a piano thing on it, and that would map a little bit better. But for like you see like the play pause button, this is the specification for the play pause button, but it also, if you look at the English scale section, it'll actually say it's also a lot of these are designated as like which note it would correspond to, and also which octave it is. So let's say like the play pause button, B-1, the shift key D sharp 4. Let's see what else is there. If you just touch the jog wheel, it's F sharp 3. So so both sides of these, yeah, they might have the same scale, but the overall, like MIDI in and the MIDI outs are going to be a little bit different, so that you can actually differentiate between the two. So that's really you can look at all they list pretty much everything. So like you have they've got all the pads, more pads, and then of course this has lights on it. So lights. I don't think this has differing colors of lights. So some controllers the lights can show in different colors. I don't think I think this one only will show like just one type of color per illuminated control, which can make it a little bit easier for actually mapping things, right? Obviously, this is the OpenBSD man page for the MIDI open function here. Let's see. I don't think I had it open yet, but anyway, yeah. So this is the ALSA sequencer server. It is a port in FreeBSD. Yeah, like I said, I tried it in Mix and it crashed, unfortunately. Well, Mix crashed, not the sequencer server. We need to figure out why that is. But it works with Sound.io, and actually with Mix, the MIDI capability is via a library called Port MIDI, and so it supports Port MIDI. It's also a port in FreeBSD at least. So pretty much it's just an accessor library for various different user space sequencers. So of course you've got Port MIDI Linux, I believe here. I believe this directory is, it's ALSA and then the null. But they added Sound.io relatively recently, like as in this year. I don't know if the Sound I/O support has made it into the port yet. I'm actually using I'm using my local copy of the port that includes this, and yeah, they just added it like relatively recently, and I actually want to show here. It's actually the MIDI interfaces that would show up in port MIDI. It's actually hard coded. So on my home setup, which let's see if I can pull the picture up. So here's my home setup. So both of these actual turntables are their own USB audio interfaces, class compliant. But in this setup, I'm not actually using them as the audio interfaces. Like, so now that I have this as part of the setup, I can use all 4 decks. But the issue is, if I want to do that, then both of these turntables I actually need to put real records on, and not the control, the time code record like I did before. But yeah, so these 2 turntables show up because they also have a USB audio interface on them. They will also show up as such. The mixer also has a USB audio interface. So that's already 3 different audio interfaces. And then tack 1 controller, that's 4 USB audio interfaces. And I believe if I go back over to this, it kind of iterates through these, I think. If I can find the little line that I had to, here it is. Yeah, so when it does the initialization of the Sound I/O, it's just, it's going to, they just hard coded like the MIDI through, raw MIDI, regular MIDI, and then sound card. And they kind of just hard coded it to 4. And I believe on my home setup, I think there's like a couple more USB audio. There's like 2 more USB audio interfaces that you can't really see in the picture. But there's like 2 more that are attached to that basically sit between the turntable and the mixer, because you have to get the time code signal from turntable into the computer. Computer can interpret that. So this is going back to the other topic that I did, BSD-CAN. Timecode signal goes into the computer. Computer basically, or Mix or XWax, which is really the software that does it, it will recognize the timecode signal, place it directly into whatever track you selected at that exact point of the track, and you can just control it the same way like this. And then the output of that track goes to the other USB audio interface back into the mixer. So 4. Yeah, well, oh yeah, let me do that. Let me see if I can do that. There we go, yeah. Is that good? Yeah. So as you can see, like they specified the Sound I/O's MIDI through, raw MIDI, and the sound card, with IJK and all that stuff. And when they do the little iteration in this init function, they kind of hard coded it to just 4. So it's like, so you'll see like, MIDI 0, MIDI 1, MIDI 2, MIDI 3, and that's it. So I actually had to patch my own local copy to, like, I think I changed that guard to like 6 or 7 or something just to be safe. And that was, and then it was only after that I was like, okay, I finally got this thing to connect. So just a little, it's a very minor snag if you actually know how to, kind of go through a little bit of C. I'm not going to pass any judgment on that part. But yeah, this is just like I said, they only added this like relatively recently. It's still relatively rudimentary. So it's not like the ALSA sequencer where in Mix I can actually see the full name of the device that it would come up in the operating system. This is like in here with Sound I/O, they just have, it just says MIDI 0, MIDI 1, R MIDI 0, R MIDI 1, etc. So that's that. Let's see, what else do we have? Yeah, so this is actually a newer version of that all-in-one system I was talking about. So it's the similar setup. It's just a newer model, but you know. So this is the central operating system screen that you would do things in. There's still places somewhere to plug your USB in over there. You have all these part numbers that correspond to MIDI stuff. Yeah, and I believe I should have, so if I go over to the mix repository, if I can find it here, I think it's in here. Yeah, let me just duplicate this tab. Move it over here. Cool. So this here, this is the directory for, and I'm gonna have to make this regular size again temporarily, but so this is the subdirectory in the mix source code for all the officially supported MIDI controllers. So the way that you can, so you basically have to map each different MIDI message and whatnot into the equivalents for mix. I mean, it's kind of similar concept to device drivers almost, something like that, but instead of kernel space, you're dealing with user space for the most part. So let's go over to Pioneer DDJ Flex 4. So normally, most of it is this XML thing. And as you can see, so you go to, let me find the play, pause, deck 1, okay. So here's play, pause, deck 1. So Mix has their own like, you know, descriptors or whatnot for each piece of functionality that the program supports, and then you just have to, it's just a matter of mapping whichever one it is. So if we go back over to DJ Flex 4 for the play, pause, deck 1. Play, pause, deck 1 is part number 1-1. So you see here, you kind of go with you basically match up the different hex for the MIDI in. So you see 90, status is 90, data 1, 0 Bravo, data 2, hotel, hotel. And you see here the status, they matched it up, 0x90, and then 0x, 0 Bravo. So you kind of, so normally, so Mix tries to encourage you to use their wizard to kind of do all these mappings, you know, so that they have this learning wizard where you can kind of just like press each individual button or use each individual like touch function or the jog wheel to kind of match the functionality up. So you don't necessarily have to handwrite everything. You might still have to do some handwriting, especially when you're, so there's also a script side of it. There's also a script side of it, especially for like the lights and the jog wheel. So you see the lights here, lights, and you know, so this is all like JavaScript. You know, there's some timers, you know, jog wheel constants, multipliers, loop, adjust, you know, all the different beat jump pads. So when I go to the beat jump function here, I can actually, so some DJs, especially the ones who are used to digital systems, sometimes instead of doing this manually, they'll actually use the beat jump function to jump, you know, if it's like, you know, like a 4/4, they'll jump like another quarter note or a half note or, you know, ahead or backwards, something like that. It's a little convenience feature. Yeah, more LEDs, you know, things like that. So I think, I don't know if Matthias is in here, but me and Matthias were talking, we were talking a couple days ago at the conference, and he started messing around with the mappings with his controller in the mix, and yeah, he realized it was a lot more involved than what met the eye there. So yeah, that's much of the whole, like the basics of like just getting the stuff mapped over. I mean, of course, okay, we got 10 minutes. Yeah, 10 minutes, something like that. Don't really have too much left. I mean, if anyone's got any questions, feel free to ask, but I can also do a little bit more of a little demo of the program here. And in fact, I'll just move it to the other monitor. Let me see if I can get it over. There we go. So this is the user interface of Mix, the DJ software that I use while it's open source. Apparently started off as somebody's PhD thesis, or parts of it started off as somebody's PhD thesis, but ever since then it's become a very big community project. You know, for those who don't want to use Rekordbox or Serato or anything like that, it's got pretty comparable functionality to it. So let's see, so right now I'm using this selector jog here, and I can go between menus like that. And I'll select something here. I'll put two of these in here. I'm also going to adjust the pitch all the way up, because one of the basic things in DJing is you want to match the beats between at least two tracks, and of course you want to make sure that doesn't sound like crap either. So that's why you've got the equalizer here. I think I used this one, so I'll load this, and I believe I've got. So as you can also see, as I'm kind of moving these up, I actually have I normally don't have the display up, the display of the digital controls, but I just have it up just to show everyone that, you know, when I actually move the fader, it moves along with that. And it's the same thing with pitch fader. And if I do this, that's the low, that's the bass here, that'll work too. And then this is the filter. And filter you kind of select in the software. When you're on especially like a Pioneer mixer, they have like different buttons for filters that you can select. But in this case, you select it in the software. It's just a matter of whatever the software supports. So yeah, I guess I'll do a little example of this. I want to make sure this is also matched up. So on an actual turn, so I don't really care too much of like actually seeing like the exact BPM or anything like that, because I'm used to spinning on actual turntables, and you don't really get that information. You kind of just have to keep doing like little adjustments, you know, as you go. But in this case, we have a little bit of a convenience feature, so I'll kind of do a little preset so that it's just about matched up. So I'll get that going. I'll let that go for 8 bars. Then, so normally I would also have headphones to kind of cue in the headphones, but I'm just gonna do this in public.
Yo, pero disculpame, ¿con quién estás hablando? Pelotudo. ¿Ah? Pedazo de forro imbécil. Cállate la boca, la concha de tu madre. De ninguna manera, ¿qué será? But we don't take no talk from you, like we never saw you in that era. But we never saw you in no lane and alleyways, giving up Bluetooth share. I said nunca te veía, estás adentro, no quieres estar afuera.
That's enough of a demo for that. But as you probably saw when I cued put the other track in, I noticed that it was just a little bit off. Just a little bit off the beat. So that's why I used the side of this to kind of just nudge it forward, like a very slight, you know, nudge forward so that it matched up. And then of course, at the end of it, just for a little bit of comedic effect, I just wheeled it back and just put it down here. Yeah, I think that's about it for much of the talk. So I guess if anyone has any questions or tomatoes to throw or anything like that. Do we have a question, Mike, somewhere? Okay. Anyone had a question?
Coming from
from being a person who just barely put in a MIDI piano into a computer via USB. I know MIDI is old. As I understood you is, if you have such a MIDI device, you don't actually need the full documentation like you have shown to us. You could actually tap on a button and then map things using Mix, or do you absolutely need the documentation to get things started?
Well, I mean, like the documentation certainly helps. And so I'll actually show here, if I go into the preferences window, and that needs to go over here too. You see over here the controller. So right now I'm in sound I/O mode. So for some reason it's like, in this case, it's on the default channel. I don't know why. But yeah, so here there's a learning wizard. So this is what I was talking about with the whole, like, you don't necessarily have to handwrite it, but it's always helpful to have the documentation in hand to be able to, you know, so that when you like use a specific function that you can like properly map it, you like make sure that it's kind of like checking like the work of AI, right? Like a lot of the times, like when you're using AI to, like, you know, write something silly and yet it still gets it wrong. It's just a way to check your work. So there is a learning wizard for that, and yeah, that's the, yeah. Actually, any other question? Okay, you next.
I'm guessing that Mix also has some functionality for controlling lights and such. Have you played around with that?
I don't believe so. I think this is more strictly for just DJing. I think the lights you're probably better off having some other forms of control for that. You know, just a completely different control surface, completely different system, whatever. Mostly the kinds of music though, like that I mostly spin, like the ideal party is where there are no lights. Like you might have just like one light, you know, just to illuminate the controls, but that's about it. Everything else is dark. I think you had a question here. Down here.
So all of this is like track-based, or is there like also synthesizer input or something similar, or do you also need other control surfaces?
So this DJ software. So DJ software is generally just track-based. I mean, some people, I've seen some setups where they have a separate controller for, you know, like if they want to do like, you know, just a random sound effect or anything like that. In fact, I'll actually show you just real quick, just a very quick little in the production software, if it'll launch from the menu here. But yeah, no. So like so in like a live situation, I've seen like separate control surfaces for that, you know, for sound effects or synthesizers or whatnot. But theoretically speaking, you can use this in the production software. So this is LMMS. I'm just going to temporarily connect the triple oscillator here, and now you can do. Oh, well, I think I have to go in the piano roll for that. Let's see. Okay, I have to. Essentially there is you can actually use MIDI. So okay, sound I/O MIDI. Yeah, I'm already there. Let me just change that here. Enable MIDI input. So I can do it like that, but I think it's, yeah. I didn't really prepare this part, but when I was testing it the other day, if you actually press, you know, like the pads or the buttons. Remember when I showed you that documentation that it also had like a column for like what types of notes it is and everything. It actually does do it, but of course the mapping here is a little bit messed up for that. So, yeah. more questions?
So MIDI is not node space, it's like a key code, or it has like...
Yeah, pretty much. Yeah, I mean like the...
But it's not just presses, I guess. It's also like the faders or something more detailed.
Yeah, yeah, so as you can see, you know, so if we go back to this here, you see these parts, so 3-7 is the, where's 3-7? Channel fader. So these are the, so that's a slide, and then you see here whatever column it is, so here's the MIDI assign reference, here's the, so what you're really looking for is this MIDI in thing, and pretty much if you're going from bottom to top, that's the payload. If you're going from top to bottom, there's a different payload for that. And it's a very similar deal with the jog wheel and everything else. And then after that, it's just the, you figure out the JavaScript or however other like, fine-tuned software control that you need. But from a basic MIDI perspective, you just map, like this. So each direction has its own mapping, essentially. Any other questions? Going once, going twice. I sound like Dan during the auction here. Sold. Thanks, everyone.
Yeah, probably 10 seconds or so. Just want to turn this on silent. All right, so hello everybody. My name is Rob Kaiser. As it says, MVP to production. I had somebody ask most valuable player. No, I'm sorry, I automatically use acronyms. Minimal viable product. I come from startup land, and so that's what that is. Very much a, hey, look, it works, transition into this is something that's reasonable that other people could run if they wanted to. And yeah, we'll go over what it is. Very brief background about me. I've been using OpenBSD mostly on firewalls and networking appliances since about 4.1, 4.2, so a while. At the same time, my background is varied in the sense I've been a programmer, I've been a sysadmin, I've been SRE and platform and CTO of a bunch of different startups. So I tend to come up with solutions that are not ideal for anybody. And by that I mean I annoy the programmers and I annoy the systems people because I tend to solve problems using a very large variety of solutions. And that sometimes leads to things like this, where everybody's kind of looking at it going, why would you do that? Or, you know, that maybe that isn't the best idea. So, let's make sure I can hit play. Good. Okay, so I called this thing Raxt. Feel free to call it something else. Right now, that's the name of it. It is a fuse file system utilizing Elixir, specifically for OpenBSD. And that, if you understand all those words, we're in good shape. There will be a slight introduction because I had some people come up to me and be like, hey, I don't know what that is. So we'll go through some of it, but at a high level. This talk is going to focus as much as possible on kind of the productionization of this system as opposed to here's the system. So that's what we're planning on doing. We're going to briefly go over kind of the overview of Fuse in this context, Elixir and the Beam, Raft, and Kepri, mainly because it gets you all of the building blocks to then put it together to go, here's the system and how it works. There's some architecture diagrams. We're going to go over kind of making this usable for other people, right? So splitting up so you've got a controlled program, you've got a daemon, those kind of things, the communication between them. Yeah, improving security, handling failure cases. So first and foremost, why do this? Relatively simply, I still am running a very small 3-node system, and they're geographically distributed, and I wanted to store some state. And so I found myself these controlled with Ansible, pushed out the door for my laptop or some other server, but I wanted to actually have, say, sessions that were synced between all these 3 nodes. And the traditional way to do that is to use either like an HA data store or a distributed data system of some kind, but you need some kind of data system to store it, whether that's a database or whether that's a file system. That's simply it. That's what I wanted to protect against. So I'm running nodes in Toronto, New York, and Amsterdam, and the notion that I had was I wanted to make sure that if I had one node fail, the rest of the systems that I ran would not have a problem. And that's really attractive for certain systems. Not high throughput, not crazy things, but it worked really well. So that's what I'm solving for, just to be clear, and that's what this is designed to solve for. You can abstract this to a much larger system, we'll get into it, like you could run nodes of 20 or 50 or probably hundreds without too much worry, but that's not really what it's designed for. So as I mentioned, the requirements are mainly just so that there's certificates, tokens, those kind of configuration files that are available on all 3 machines. So if I create a configuration file for a user, let's say, for some random application or daemon, I want that to exist on all 3 nodes. And I want to have it such that if one node goes down, the other 2 still have the ability to read and write that file and update it, right? And that if it changes, when that node comes back online, it picks up the changes. So I wanted this to work on OpenBSD. I have these 3 nodes running OpenBSD, and the whole point was withstanding one node failure. There was a very strong preference to avoid complexity. So I did this a while ago where You can do this with just OpenBSD systems, where you have iSCSI at the bottom. You then basically have 3 nodes. They all mount each other's iSCSI systems. You then use soft RAID, and then you have basically a RAID 5 system that can withstand 1 failure. The issue with that is then you have a block device that's RAID 5. You still need a single writer from a file system perspective, which means that you then introduce NFS and CARP to make the NFS available. And then I ended up relying on the CARP system, the CARP master-slave relationship, to get basically the write bit on that file system. So because if you have problems, if 2 machines write to that RAID 5 system at the same time. Yeah, also it's complicated for other reasons. I did this because I was already running Elixir and the Beam on these 3 nodes. I'll repeat the question.
You to do something so complicated instead of just putting the configs in the Git repository and repeatedly cloning it for everyone with a threshold so that it's quickly replicated.
Yeah, so the question was basically why did I not use a Git repository or some other mechanism to push out the configuration changes? And the simple answer is these files were going to change, and they do change when they're live. And so I push them out, they might change on the server, and I want that change to be reflected in the entire system. And so it doesn't really work well to have, yeah, that's the simple answer. Also, I would not recommend doing the NFS CARP soft RAID iSCSI. It was a pain, I wouldn't recommend doing it. It worked though. And as I mentioned, I was already running Elixir in the Beam, and so this was a natural stepping point. And as mentioned, in a DCH, for the people watching online or who are watching this later, there is a great talk that is in the same conference. Some people probably saw that, a lot of people probably saw that at DCH. 25 years of what it's about resiliency. Those are the 25 years in resiliency are the things that are in my head related to the talk title. But it's a very good talk. And it points out that in this context, there is a single writer. Reads are distributed, but it is a single writer system. So you're not getting a huge amount of throughput. Very simply, I didn't want to do other things. This is kind of why. So S3FS is what I immediately reached for. And that's only because I've used it in other systems for this kind of very simplistic system where I just needed some kind of a storage system that was highly available. With OpenBSD, the version of Fuse that is available limits the file systems that are available. And so I couldn't reach for S3FS. It is possible to do iNotify tools and rsync if you get really fancy with how you're doing things and have a translation bit in the middle. What you can do is you can have it be, so iNotify is basically something changed on this file. You would then have to set up a ring, and probably a bidirectional ring. You'd have to have 2 rings, and you'd have to manipulate so that you don't have loops, and you have to change it when it comes back so you don't have a loop. Don't do it. It's not designed to do that. Ceph and S3FS within a Linux VM is probably the most reasonable alternative if you are running OpenBSD on hardware and you want this functionality. That will work, and it will work reasonably well. As I mentioned, the software RAID and iSCSI is an option. Sharp edges. And it is worth mentioning that you could use a software RAID and then put a Fuse file system on top. And the reason you might want to do that is it changes the problem. It means that your block layer guarantees certain things, which is a different solution. So I'm just mentioning it as it's a thing you could do. For the people who may not know, most people watching this talk will probably know, but there's the overview of Fuse, down and back up, the notion being that it's an application that defines a file system. So you do an ls, you do a get adder, you make a directory, you do something in the file system. That event goes down through the kernel and back up into an application that has a callback defined. That's the very simplistic, there you go, kind of. Pretty much exactly what was just described. It's not, not in the kernel is I should have worded that better. Not in the kernel is basically your program doesn't have to be in the kernel. right? So you can have a C program if you wanted to, you can have an Elixir system, you could have a Python program. All these things can define a file system and actually interact with it and define what the files are in the directories and that kind of stuff. And there's probably about 2 dozen different callbacks that take reasonable inputs to what the files are. The man pages are pretty good about this, and it is worth mentioning that they are very well structured and they are standardized in terms of they map one-to-one on what you would expect a file system to do, generally. There's a note about Fuse basically versioning here. Fuse has 2 different versions. So you've got the user space kind of API, and if somebody's talking about a Fuse version, they're probably talking about a user space. And that's what applications target, right? So if I'm writing a Python application or an Elixir program or something, that's what the version it's going to target. And that's an abstraction layer into basically libfuse or Fuse, an implementation of Fuse. Depends on what distribution you're running on. So for example, in NetBSD, it's Puffs, which implements a Fuse compatibility layer. But with OpenBSD, it's basically, there's an implementation of Fuse that's compatible to a specific version. In OpenBSD's case, it's 2.6-ish. Then there's a lower level version, which is the boundary between the kernel and the Fuse system. As mentioned, OpenBSD, roughly version 2.6. Most file systems require 3.x. That's why I'm talking about it. There's 3 different file systems in ports, and they work reasonably well. There are some changes hitting TechAd with updates, so that should be good. And I'll be full disclosure, I should have done that. I should have said, instead of doing this shenanigans, I should have said, how can I work and bump the Fuse version? Not the best C programmer in the world, figured file systems in the kernel, probably not the best starting spot, but still worth mentioning. This would have been a good idea for me. So I used Elixir for this, and if you aren't familiar with that ecosystem, it has a very long history. There's a lot of conferences, and there's a lot of overlap. There's a few people in the room who are actually working in that industry or with those systems, and it works really well in these kind of environments. I'm running 3 nodes. I want them to talk in certain ways. I want the failure cases to be well defined. It got its start in telecom, right, where you want these phone networks, these switching phone systems to stay up a long time. So you have to handle failure because it's going to happen. It's known for stability and scale. That's the big thing. That's roughly what it looks like. So I'll go into it a little bit more detail. There's like 4 slides on this just to give you an idea of the layers in this cake so that you have an understanding as to why I chose to use this in the first place. And honestly, if you're doing distributed systems and you're not familiar with Erlang or Elixir or the other languages that run on the beam, highly recommend you look at it because it's a very well-tuned system for certain problems. In OpenBSD, you can just package add this and you get all that. So it's not too bad. ERTs, you've got a garbage collector, scheduling and an input-output. Basically, this is the layer cake on the bottom. The scheduling is the big thing I want to highlight here, where in the Elixir system language, let's call it that, let's just say Elixir, there's a bunch of stuff in the middle here, but you have this notion of processes, and those processes are very small, and they don't share memory, and they are aggressively scheduled. And so you've got a scheduler at the bottom. You can have hundreds of thousands or millions of these processes running at the top, and you've got basically a scheduler down at the bottom that has X number of threads. You can also run multiple processes because of the fact that it's all empty, like it's all message passing at the top. But basically the scheduler is very aggressive about context switching between all these things, and it's very optimized. This is enabled by a virtual machine. It is register-based. It has a fairly simplistic instruction set, simplistic being relative. It is heavily optimized, as I mentioned, for pattern matching and message passing and concurrency. So that's the whole point of this, right? So at the very top, you've got all these small processes. You're going to send messages back and forth between them. So hopefully you can get an idea of why I wanted this for my system for distributed storage. You've got the standard OTP, which is, very roughly speaking, standard libraries as well as standard ways in which you should do things. It implements certain, what amounts to an API. It's not actually that, but it's close enough. So there's standard ways in which you talk to these processes, and if you implement these things, you can then use them in other places. The design patterns are the big one here, and a lot of the value of this stack comes from the design patterns. And you've got a functional language. Highly recommend it. It's a great time. It also works really well with these kind of things. That's to give you an idea of what the flavor is, what it looks like. I haven't run this code. I've looked at it and went, yeah, that's about right. But just to give you an idea of how it's set up, on the right, you're going to see basically the notion of a module. The idea would be that there is a process. You can think of it like an instance of that, and that would live with its own memory and its own system. And on the left, you can interact with it. So you send it messages. In this case, you're sending increment, and then it will increment the thing and then call itself, and it will wait in this for. Basically, this process will continue to sit there and wait to receive something. And the basic notion, there's a lot of complexity in here. I'm not going to get into all of it. It's about Fuse and OpenBSD. I just wanted to mention there's a reason why I went this way. There are 2 slides that are similar to the DCH talk. I recommend you go again and watch the DCH talk in this conference track. Highly recommend. This is one of the 2 slides that are very similar. The Raft consensus algorithm, for those who haven't gone and watched it or don't want to for some reason, it is designed to be easy to understand. It is a distributed consensus algorithm. The idea is to get multiple different systems on the same page about what is and is not the current state. It has a strong leader, so that means at one point in time, there is one leader, and you have to trust that leader. So it's not Byzantine fault tolerant. You can work around that, but not really. And it has guaranteed consistency, guaranteed in certain cases. If you are interested in this, I highly recommend to take a look at the Raft GitHub IOs. It has a nice visualization. It has a nice interactive system where you can pause. It's actually an implementation of Raft inside JavaScript where you can pause and you can see these interactions happen. So, it exposes replicated state machine. It's very popular. It's running in RabbitMQ, Kubernetes, Kafka, ClickHouse. Take your pick. It's all over the place. You are probably running it somewhere in your technical systems. I'm not going to go over all of this. The big thing I wanted to highlight here is you've got a client. It interacts with this boundary here, and you get a state machine. And that gets replicated out. So you can treat it like a state machine. Those are the states that it can be in at one time. It's a very simple way of saying you are either a leader, you're proposing yourself to be a leader, or you're a follower. This is all abstracted. I'm mentioning it because it's that easy, and it is possible for you to mention this offhandedly, and people can understand it, which is useful and new, compared to Paxos and a few other things from years ago. Compaction of logs. So you had this append log, and then there's a mechanism to apply it to the state machine. You need some way to compact it, because otherwise you get infinite logs. That puts a bound on how far behind a certain node can be. And yeah, okay. We're getting to the end of this, by the way. We're getting to the actual thing. I just wanted to, you've got all the steps now. The last one is Kepri, which is it's a package in Elixir. It's written in Elixir and Erlang. I think it's, yeah, I'm not sure which anymore. It's on top of the OTP. You can use the languages back and forth. It comes out of RabbitMQ, but the basic idea is it uses Raft, and it provides a tree-like structure. And it is basically a distributed file system right out of the box. So you have a directory structure path, like a path that then translates into a tree, which gets stored in Raft. So it's pretty much exactly what I wanted. So there's a demonstration. I'm gonna run the recording of the demonstration just to go like, this is the notion. That's kind of the architecture, so you have some sense of what you're looking at. But the notion is you've got a daemon that runs one on each node. They talk to each other. there is a separate program over there that uses a SOC just like the other systems in OpenBSD to basically communicate with that daemon to say, hey, I want the status or do these things. And there's a child process that kind of talks to Fuse. And there's a reason, I'll get into the difference between RaxD and RaxD Fuse, because you don't want one to fail. You can have one fail, but you don't want, you want to make sure that RaxD doesn't fail. So if RaxD Fuse fails, let's not kill RaxD. So I'm going to full screen this for people. This is, I think, let me just check the time. Yeah, it's 1 minute. It's fairly quick. I'm going to describe what's going on as it goes. Full screen. So there are 3, hopefully that's reasonable text. I can't actually bump it, I'm sorry. So if it isn't, I'll walk you through it. But there's 3 machines, and I've got debug streaming on the bottom for each machine. So top is the machine, bottom is the actual daemon that's already started. So you can see that all 3 of them have a Fuse file system mounted. The middle one, you can see it's empty. If I echo foo into a file on the other one, it exists. You can echo bar onto the same file, overwrite it. And then on the third one, it now has bar. You can then, I'm going to pause it right there. There's a very simple show function out of raxctl. It gives you ideas of like the current clusters. So what nodes it's connected to, whether or not Fuse is enabled, what the mount point is, basic stuff around who is the leader. At this point, I killed the bottom right. And so I'm going to say, you can still read and write. I'm going to change the content, create a directory. Creating another file inside that directory. You can see that it exists on the other node. The content is there. And if I spin up that node, it comes back. It caught up with other ones. It mounted it, and now my files are still over there. So effectively, there was a cluster. Everybody was in sync. A node went down. Changes happened on the other 2. It came back up, and it just magically came back. Yeah. And the same thing with this. So it's literally just the same thing. That's me having a typo. And you can see I restart it, and you've got the content all. That's the whole thing. You probably don't need this, but if you do, it might be really handy. So getting back to this. A little bit about this. Those 2 applications are actually e-scripts, which basically just means they're not quite binaries. They are binary data, but they are actually scripts and require the Elixir system. I would probably change this. If this gets any traction, I will change it. But the notion is that this was the easiest way to kind of make it work right now. Basically, Elixir is required. If you do it properly, if you do it a different way, you can make it so that Elixir is not a hard dependency on the system. As I mentioned, communication is done over a socket, and message pack is used for serialization. What that translates to is basically JSON, but binary. It's not quite that, but it's close enough for the purposes of this talk. Mentioned RaxD Fuse, listens on standard in and replies on standard out. So you can think of it like it talks Fuse down to the kernel and then has standard in, standard out. And that's it. And it basically takes events coming in and sends a message that way. And then it takes a reply back from there and sends it back down. There's some atomics in terms of references that exist just to make sure that async communication can be matched up, but that's all it does. Related to simplifying operations, so just to be clear, I had this working very simply a while ago, and I went, hey, I should make this better, so I submitted a talk to here, and trying to make it a reasonable thing for people to adopt. So on the right, you can see an example of that's the entire configuration you need. So you just need to specify the peers and a mount point. The other defaults are same. You probably need a listen IP though too, because unless you're running localhost. Binds to localhost by default. It does require a single TCP session, a TCP connection out to each of the nodes. but it will use the IP that is listen IP for egress as well as, so if you have a node with a bunch of IPs, it'll use it for egress and listening. Yeah, that's that. But as mentioned, show, that's basically it. It gives you the overview of what's going on. I will add more stuff into this over time, but it gives you an idea of what's going on. Related to handling failure, I didn't want RaxD to fuse to fail and cause a problem for RaxD. So there's an option for remounting. The notion being that if you have that C program fail, you probably want your files to still exist. Otherwise, the directory structure you had in that fuse file system just isn't going to exist anymore. So it comes back with that option. You can disable it, but it comes back with that option. The peers will automatically try and connect to each other all the time. If they lose connection, they'll just infinitely retry. And that's a design decision just because I wanted this to be simple, stupid. And as you saw, automatic recovery, that's kind of gifted to us by way of Kepri, which automatically handles that for simple cases. For 9 times out of 10 cases you're going to hit. Communication is a single port. By default in Elixir, there's a port mapper that's used most of the time. I picked a port that wasn't assigned as far as I could tell, and just went, here you go, there's the default. You can obviously specify it. It's not a big deal. And for the people in the room who may know Elixir releases, or like basically in that ecosystem creating a binary, I did not create a release. These are e-scripts. And I would change that if this gets any traction. Mainly because then you end up with a binary that you can then move around and do an actual, it'll run on any OpenBSD system that's the same architecture, as opposed to having to have Elixir bundled with the operating system. Under the hood, it uses EPM-DLIS. It's a very fancy, you don't need to care if you don't need to know Elixir, but basically it's just, they're talking to each other directly and you have control and also the downsides of that communication. You have the responsibility to make sure those nodes are connecting together properly. And if you don't, they won't. There are 2 C programs in this system. So really there's 2. So there's a NIF, which is basically just a very fancy way of saying a shared library in Elixir. And what it, with the right option, it will call pledge, and it will also drop to nobody. And that's a fairly straightforward thing. I will add unveil into it as well. And right now it's running on one of them. I need to get the ordering right, but it should be reasonable to get the other especially if I were to move to a release, you could get all of the programs, all of that entire binary to be respectful of pledge. Right now, it's half respectful of pledge. One thing that came out of a conversation I had, set UID is a scary thing. In this kind of a context, what happens if the other node over there sets something as set UID root, right? So in the C code, in RaxD fuse, it's a very straightforward check. Every single directory and file match very specific modes. That's it. You don't get anything else right now, mainly because I don't want to have to deal with it. So there isn't any set UID root because the program that gives back to the kernel what is there has a guard in place to say you will only ever see these modes. This is the bug I'm currently stuck on. I mentioned it. I'm putting it in here because I expect I'm doing something wrong. I will go and find my own problem, but you can see that effectively I have a system mounted, and by the way, I am using the user ID and the UID and GID for the fuse mount. As I'm root, you can see that exists, and it's user. If I become the user, that suddenly changes. And I think that is OpenBSD Fuse implementation. I'm not entirely sure. But that's currently what's blocking me on adding in a bunch of basically ownership into this as well, because Fuse, obviously you know who owns what. So my plan is to add in, specify the user that you want these files and directories to be. It'll play nicely with unveil. Everybody will be happy. I need to fix this first, or at least address it. Next steps. Ability to run export import. This would be really cool if that system worked and then the thing automatically copied, so you had what amounted to a dirty read, right? If you had a directory that was local to each node that was always guaranteed to be there, it gives you some guaranteed consistency, even if it's not, you know, you might not have the updated thing, but it has it also removes the dependency on this whole fused file system thing, right? So I want to add that in. The mount point ownership, as I mentioned, it gets me chown, chmod, all that stuff. Right now, it's just kind of saying, get rid of that problem set right now. There's nothing saying you can't add and remove nodes in runtime. Capri supports it, Elixir supports it out of the box by default, and so it can become really interesting. Yeah.
You store the file content in TFT's in-memory database?
Ah, thank you. So I will address that, I swear. If it's not in the slide deck in the next 2 slides, I will come back to it. So the question, just for people on the recording, was where's the actual content, right? So we've defined this thing, but where's the actual content? Yeah. Oh. Yeah. Yeah, go for it. So the simple answer is no. Right now, I am using a user and a group, and I had the -d flag as an example just when I was debugging stuff. So it is quite possible I'm missing a single flag, but. Thank you. That solved my problem. That's cool. That is awesome. And it's odd to me. Well, yeah, okay. That would explain that. So thank you. Yeah, unblocks me. I appreciate it. Yeah, and that's it. So I'm gonna, one more thing about where the files are. They're actually stored in, so Capri has this distributed storage system. It uses a system called DETS, which is disk-based ETS, which is a very fancy way of saying there's a standard way in which in the Erlang and Elixir system, you can persist things on disk. Your data lives there. It also lives in memory. This is not optimized. You have limits on, your file system is living in memory as well as on disk. It also is limited to about 2 gigs, I think, by default with a single DETS table. The point is that this works. I'm not saying it's perfect, but it is stable. I've been running this for, it does its thing. So that's where your data lives. Right now, you get a directory structure that you can't easily get your files out of. So without 2 nodes up. And so the export import is why I want to enforce that, so that you have a way to automatically have your files in a usable way from a system administration perspective, no matter what happens to that. So you specify a directory. The other way to look at it is there's a directory that's basically a database that is relatively opaque. It's not actually opaque. You can go digging and get it, but from a high-level perspective, it's opaque. I think that's it. Yeah, it's available. Feel free to, take a look at it if you want. There are things I could do to improve it. If you're interested in this, and this is something people are actually interested in, I'm happy to spend more time on this. But this came out of me kind of solving my own problem of very simple configuration and not having a viable option that was specifically for OpenBSD. So yeah, that's that.
Gift from us. It's Thai. Croatia is known as the birthplace of the Thai. So,
thank you very much.
Okay. Are there any questions? Yes.
I might have missed something, but is there a specific reason you're dropping to nobody and not using a dedicated user?
The simple answer is no. The reason...
Okay, so don't do that. Nobody is only for NFS.
Fair enough.
You want a dedicated user.
Yeah. My plan is to expose a configuration into the system to let you specify what user you wanted to drop to. I was trying to develop this, and I hit a bug where I couldn't actually get that going. And so I went, I'm not going to continue to add configuration into that right now until I get usable responsiveness from my options, which sounds like I just need a single flag. But thank you very much for that.
What you want to do, if you want to make it into a port, you want to create a dedicated user, add it to the users list in DB. Even if there are no IDs left, we are working on that right now. And then when you get the port, you'll make sure you have it. If you already have a proof of concept, maybe you can reserve the slot already.
Thank you, yeah. As mentioned, I have not packaged this up into a port. I expect to add in these couple extra features and make it reasonably stable, add some tests, and then put it into a port so that it's at least an option for people. That will definitely happen before that, so thank you. There was a question over there? 1, 2, 3.
You mentioned someone is working on Fuse 3 for OpenBSD?
Yeah, so I'm not sure if it was Fuse 3, but there was a couple notes that I saw hit the Tech Atlas. Helg is kind of looking at that. I basically saw them come past. I haven't looked carefully. My understanding is there's some work to be done to allow for that.
Okay, thanks.
Yeah. There was 2 down here, and then 3 right at the back.
I didn't quite get what you're sitting on top. Are you sitting on top of the userland library, or are you talking the protocol directly?
I am sitting on top of, I'm calling, so there's a C program that calls, Fuse setup, let's just say. I think it's Fuse setup. So I'm calling that with the C interface into the kernel. Does that answer your question?
I think so, yeah.
Thanks.
Sorry.
Very top left.
Not exactly a question, but you mentioned the SUID binaries being kind of scary and everything, but there is an option that you can pass when mounting for the kernel to ignore that bit entirely, and then you don't even have to think about it.
Okay. Thank you.
Any more questions?
I'm sorry?
As the Fuse server, you can also mask the permissions.
Yes, exactly. As the Fuse server, you can mask the yes. And there's probably an option to set it. Yeah, perfect. Yeah. Any other questions? Okay. Thank you very much.
perhaps for FOSDEM. We'll see. Shall we go? Okay, good. Hello, hello. I'm Stefan, for those who don't know me. I'm involved in OpenBSD in doing various things, like in particular Wi-Fi. But in parallel to that, for years I've been working in version control system stuff via a consulting company where we also contributed to Subversion. So from about 2009 to now, I've been contributing there. And I've written a version control system for myself, and we are now using that as a basis for a hosting service that we want to start. So the system that I started writing sometime in November 2018 is called Game of Trees. And the tagline is that it's a version control system which prioritizes ease of use and simplicity over flexibility. It's using the Git repository format because it's ubiquitous, it's everywhere, and it's basically become a de facto standard, so it was reasonable to use it. And the Git network protocol as well to be able to interact with servers. It's designed around OpenBSD developer use cases, which are based on how people use CVS in OpenBSD with copying the whole repository onto laptops to be able to do local diffing and so on. So it essentially extends that development model that people are already using with a new data format that can be used to actually send the changes out instead of having to go to the main server, commit them there, and then have them flow back manually with CVS. It's written in an OpenBSD style C code base, and it's using the standard license for OpenBSD software. And it makes extensive use of pledge and unveil, so the whole design is inspired by those primitives that these two routines provide. So for instance, if you are cloning from the server has de facto read-only access to the data you're getting, but it cannot write to it while you're cloning. If you're sending changes, of course, it has write access, but it adjusts its permissions based on what it needs to do. There's a portable version. It's maintained by Thomas Adam, who's also doing the Tmux portable version. And you can, by now, you can install it on Debian, Ubuntu, Arch Linux, and some other distributions from packages. You can get it from macOS from 2 different third-party software trees, and you can also get it on all the BSDs. I did a small collection here to not just give my perspective, but also what I found that people have said, where it's on the internet and can be read. So in 2019, Aaron Poffenberger looked at this and fainted immediately. In 2020, Oliver Lowe wrote a nice short piece which describes the idea that the endless flexibility of Git's UI is not always a benefit. And this really resonated with me. It's like a really short blog post, but it's nice because it kind of gives the perspective that I had when I was forced to use Git for work stuff really well. It's like, why is there all this complexity? It just always kind of stood in my way because I understand how the system works, but all the layers that were added on top in the UI were always kind of working against how I wanted to work with it. There are also people who believe that we never make mistakes. And yeah, there's 2 sides to this. One is that it shows that people kind of see the value and the quality of the software we produce. On the other hand, it also means that the expectations are quite high and we cannot make mistakes. And we're certainly not perfect, so this is a very high standard, but it's nice that people see it that way. And fairly recently, in 2025, Simon Harrison wrote a small review where he was starting to try to use it just to see how it works. This was all mostly focused on the client. And it's a nice introduction, actually. It's much, if you just want to get a general idea, then this is a really nice blog post to read. So, Game of Trees can be self-hosted as a server for about 2 years now already, and some people are doing that, including the project itself and some other users. And we want to provide a hosting solution for people who are not self-hosting for various reasons. And we want to host both open source projects and private projects on the service. One major goal is to improve the quality so that we actually get real live use cases, real repositories that people are using in practice, and make sure that things work with those. And the user base should be able to use it, even though we're testing the software. It should be so good that they can rely on it at the same time. And we are quite, so the self-hosting crowd has been very valuable because they respond with bug reports and so on, and we've been able so far to fix any known issues. And also, this should be something that doesn't take over the world and grows forever, because this is nobody's main job. We have other things to do as well, and so this is something where we want to grow it to a point where we can manage it, but not beyond that. So, and the problem is if you start running a service for hosting, you need servers, and that costs money, and also maintaining the service and writing extra software to support it costs a lot of time. And we want the money that we need to come from our users. We don't want it to come from any external parties. This is really about building a community that supports itself in a way. So we want to charge the users of the service so that they support the hosting costs and some other costs on top. This doesn't mean that everybody who's interacting with the site would be, hitting a paywall, whatever. So you can add committers to your projects, and they're not going to be individually charged or whatever. It's just that somebody's there who takes the initiative to fund a part of the resources that the hosting service needs to exist. And whatever is surplus, what doesn't go into hosting companies' bank accounts, can be used to support our developers and people who help maintain the site. And the major idea is that we want to make this transparent. So when I found out about Open Collective and eventually realized I could combine this with this project idea, it kind of fit together really naturally. So this site provides you with a public ledger that anybody can go to and look at. They see what money comes in, what money comes out. I realize now, while I'm using it, that they're not showing invoices, but I wouldn't have a problem with showing invoices that relate to the service to anyone who asks and wants to see them. The Open Collective page, the site also provides a review system so that one person on the team cannot just file expenses and immediately get them accepted. There has to be a kind of peer review, which is also nice because it also encourages the admin team to stay proactive and work together and review things. And the site also allows us to collect money. We initially wanted to use this money as the source, as the payment for the service, but that doesn't work for various reasons, as I found out later. So right now, this is a bucket of money that's just used to support the project. So if you just want to support us without needing any Git hosting, but you like the idea, then you can just go there and add money into the fund. And there's quite a few people who are already doing that. And I'm very grateful for this. And you also get regular updates about our progress if you do this in your mailbox. With Open Collective, you need a fiscal host. And originally, I wanted to use a nonprofit that's based in Belgium, but they wouldn't accept the project because it seemed too commercial for them, I believe. And we ended up doing something different, which I actually, in hindsight, prefer because it gives us a lot more control and flexibility. So I have a single-person limited liability company, and we created a second bank account after I discussed the idea with my accountants. And they said, sure, go ahead, we'll try that, and it sounds interesting, and so on. So they helped me also manage all of this and all the tax obligations that come with this. This also means that there's no real way to take this over in any way without my consent. And it really reinforces the idea that this is all self-funded from the people who are using the site. And as I mentioned, the bank account is completely separate. So now I have two bank accounts. There's one where all the consulting happens and another for the collective. And I can only take money from the collective's account if there's an approved expense on the Open Collective page. So that when my company has paid, for example, a hosting service bill to where the servers are, I can reimburse myself from this account, but only with the community's approval. So the other activities I'm doing, just because my non-existent marketing department wanted me to mention this, there's an OpenBSD introductory workshop that the Linux Hotel is hiring me to run for them. The next opportunity for this is, it's a confirmed slot, so the 29th, 30 October. There's still room if you want to join this as a participant. You can go to this link and check it out. Intermission over. So the server that we have is a custom implementation of a Git server, which is only reachable via SSH. It is compatible with any Git client implementation, so you can use regular Git or even Dulwich or others. It supports multiple users and groups and repository access permissions. And when you have an account that represents a user, it's a regular Unix account, which has a special shell associated with it, which only speaks Git protocol. So when you log in there, you don't get the normal shell behavior, but you get a Git server. And in the back, that talks over a Unix socket with the actual daemon that's running on the server. It has the Git repositories. This also allows us to provide anonymous access. So the public can clone repositories over SSH by logging in as anonymous. And they can verify the server's SSH fingerprint to know that they're connected to our server. And then keep getting updates from there. So we don't use HTTPS in the server implementation. We only have some read-only HTTPS cloning support in the client for convenience, but generally we're trying to reinforce the idea that SSH is a better protocol for distributing software code than HTTPS is. And there's a longer talk about this program that I gave at FOSDEM. You can look that up if you want. There's a video and there's slides. Now for the service, as I mentioned, the user accounts are actually Unix users. So you cannot really manage a GOT server without having root access to the box. And if we were to just host VMs where people log in and have to manage things themselves, it would be kind of boring and not really add a lot of convenience. So I went and spent quite a bit of time to implement a crazy idea, which is kind of like Gitolite, but done in our system, where you can, as a user, clone a special repository which contains instructions about how you want your repositories to be called, what users exist, what their authorized keys are, what maybe their passwords are if you want that, what the permissions are. And you commit that and send it up, and then the daemon sees it there and reconfigures the OpenBSD system in our GOT server, the GOTI daemon, to do what you want. So in this way, we provide the hosting space, and you can configure it, but you never get a shell on the box. It's all done through this daemon, which is also useful for other things. So for example, we don't need Ansible to deploy VMs or something like this, because we can use this for our automation purposes. And the syntax looks like this. So you'd be cloning a godsys.git repository initially. That's the only repository you'd have when you start. And then you can define your groups, and you can add users, put them into groups, and you define what repositories should exist and what the access permissions are. You can also have the server send you notifications when you send commits. So you can get email notifications, or you can get signed JSON objects that are signed with a secret that you put in there, so that in your endpoint where you receive the JSON, you can run custom webhooks or whatever you want with that. We don't have any ready-made software that receives the JSON and does something with it currently, but it's fairly easy to write in various languages. We also have a web front end, which is only used, it's like cgit or git web. It displays repositories. You cannot interact with it beyond that. And, oh, I need to point out, we made a mistake here. So initially, this program was running in change root with the web server. And because of the needs of the hosting site, we didn't want to keep separate copies in the change root space and the space that the Git server itself is using, because that would double the disk space requirements for the service. So it was decided to make this program capable of reading repositories outside the change root by adding more processes to the daemon, and which were not in change root and which have access to the repositories. And yeah, it would unveil the path in its configuration, so it would only see the Git repositories you really wanted to expose, and that's it. However, the portable version also contains this program, and we forgot to enforce unveil style access there. In version 0.111, this is fixed in 0.118, but there are some Linux systems which haven't updated yet and haven't patched this bug. What this bug means is that if you have this thing running on your machine as some user, and this user is able to access or to read files somewhere in the file system, directories somewhere in the file system which contain Git repositories, you can simply guess the path to this Git repository by doing .. / and going up and then going down, and the daemon will happily display it, even though it's outside of the repository that the directory where you told it, here's where your repositories are. This is patched and released, but I think, so I just checked this morning. I think Arch is patched, NixOS is patched, GUIX is patched, but critically, NetBSD isn't patched yet, Packer source, and Debian isn't patched. And if you're using any Debian-derived thing, you have this bug on your machine. So please don't run it there if you have sensitive repositories that you don't want to be exposed. And please, it's just update to the latest portable release. And you can also, if you need a patch to backport, ask me. I will send you the link to the commit. It's a trivial fix. But yeah, we're not allowed to make mistakes. There was one mistake already. So we probably shouldn't be making any more of them. We currently don't have this web front end on the service. So currently, if you book a service, you only get the SSH part, and that is because the web service part was written with the assumption that it would run in change root, and there would be a separate copy of the repositories it's supposed to expose, so it has no idea of the authorization rules that the other daemon has. And that is a problem once you mix the two in the same repository space and you want to support private repositories in addition to public ones. And crucially, we probably want to hide the godsys.git repo from the web. So we needed to implement authentication in the web daemon, which is now done. It's not released yet, but it's on the main branch. It will be in the next release. It also works in portable. I checked it. It's working. But this is only the web daemon. So the next part will be to add support for this to .sysd, which does all the configuration because it needs to generate a configuration file which reflects the access permissions that you set in your config file. And also we have the issue that even the main server that we use, GameOfTrees.org, which has this daemon running to display repositories, is constantly getting crawled, and they're constantly blaming files and logging files and diffing things, and all from random IPs, and over again the same things, and it's causing a lot of CPU load and traffic. And if we have potentially quite a lot of repositories on these servers, then this could cause quite a lot of load. So we needed a way to prevent this. And there's no real best solution, because in the end, if you have an open source project, you want the public to be able to see it and browse it. But then the bots can also browse it by definition. And so you can only do an arms race like Anubis and so on is doing. But we found another approach for now, which is to, well, have user authentication, which initially was just there to ensure that we can have private repositories displayed to only the users who have access to them. And the way this works is that we added a little bit of logic to the GOT shell, which normally talks Git protocol, to also talk to the web part. And it can basically request a login token from the web daemon, which is signed and gets put in a request query string. So you can open the URL that you get from this as you log in over SSH. And once you use the login link, your browser gets a cookie set, which is signed with a different secret and a longer validity time. And you can use that to browse around as usual until the cookie expires. And the cookie basically contains the timestamp for how long your cookie is valid, and then also the UID that you logged in with over SSH, so that we can, in the web part, know who logged in with this cookie. And blocking the crawlers works simply by allowing anonymous to log in without a password and any authentication. So you log in as anonymous. You can try this right now if you want, and you get a link. And the bots who do not bother to get this link, and maybe I should actually do a demo for people who are not at a computer. They see this, and they get a 401, and they cannot run blame, they cannot run diff, they cannot run expensive operations. This has reduced the CPU load on the server immensely. So if I go and I do get a login token, I can stop Firefox and ask it to open this instead. And I get redirected to the display page, and I can browse around. And as long as the cookie is set, it works like usual. So this is also the way that normal user authentication would work, and it's a nice way to block the crawlers. If they figure this out, which they might, because, oops, back. Because they're already solving Anubis JavaScript challenges, and this is a lot easier to work around if you know how to run an SSH client. But we have someone on the team who does crossword puzzles as a hobby, so we could add custom puzzles, captchas, and things. But I prefer not to do that. I prefer to keep it simple, and I hope that this just stay away. So you've seen what we have, and this is literally all the functionality that's implemented in our code base. It's not nothing, but it's not exactly the full functionality required by modern software projects. And while we have some ideas about how to implement bug trackers and issue systems and CI and all sorts of things, we don't have the resources to write all this from scratch in a reasonable time. And to make this more useful to people who actually want to use it for real work is we have the idea to look into third-party solutions that fill the gaps. And as far as I know, there is no hosting site where you can go and say, hey, could you run Garrett for me, or could you run Redmine, or could you run this other tool? And instead, you're always forced to use whatever the software that the service deployed is already providing. You can never customize it yourself. We don't have this restriction. We can, whatever is in the OpenBSD ports tree, whatever we can put into an OpenBSD system can be used. And we can also, for example, integrate user accounts to some degree. For example, you could imagine that what will work is that you give Garrett an LDAP user database, and the LDAP database will be provided by LDAPD based on the users in the password file, so that Garrett automatically already knows the logins of the people you've added in the godsysconf file. And then if you have, maybe we can even tweak it to respect the permissions you've set, but at some point you will have some divergence where if you enable an additional application, it's on you to manage it properly. And maybe you can add additional users there who don't have Git access, but you know. So they would be a bit not the same, but maybe that's good. Maybe you want the public to report bugs to you, but not add everybody to godsysconf. So this, I think this can actually work. So some ideas I've looked up is Garrett seems to be pretty popular. I've also used it at work for a year. It's solid. It works well for users, and it's a lot of people are familiar with it. So it's not like they would have a hard time starting to use it. If they already know it, and there's review board, there's Redmine, there's JavaScript-based wikis we could add. We could also host mailing lists, and for things that require actual moderation efforts and go more into the social network space, I would very much try to avoid that because we don't have the resources to provide the moderation. So mailing lists, yeah, people can self-moderate those, but we cannot run a Mastodon instance for you as well. That's just way too much. So, but that's not a bad thing because, I mean, we're also using Libera for IRC, for example, and we don't have a problem with that, and it's available, so why not use it? Some other ideas are that we don't care whether people know that your project is hosted with us or not. So you can give us your domain, we give you an IP address, it's fixed. We know where your VM is deployed, where it can be reached. So you point your DNS at our IP. We do the Acme client dance with Let's Encrypt, and we can host you completely custom without any reference to our servers at all. And we can also teach the web servers to serve Git repositories just as if their contents on the main branch, for example, were static files. So then you can have your project landing website or your documentation or other resources that you need to host as part of your software project. You simply check them in, you tell godsysconf, hey, this repository is actually a website. Please put it under this location in my URL space. And it appears on your custom domain. Maybe you can have several custom domains. You know, this is not, I mean, web hosting is not like super exciting in 2025, but you need it anyway. And so if it's already part of the package, then why not? And it's very easy to do all this. Now talking about the money, there's this thing that because we're running VMs like whenever you book service, you get a VM deployed. It's not like we can stash thousands of users on a single server. So our hosting costs are by definition, simply by design, because of the way the system is built, higher than other services can be. And we also want a bit of money for the time we spend, simply because, for example, I've been spending quite a bit of time on this, but I have kids now and I cannot work on weekends and I cannot work in the evening. And this means I have to really reduce this to the work hours that I have for the company. The company has a business plan, it needs to make this much money per year. And it's hard to do all this unpaid work on this, mix it in with enough paid projects to stay afloat. So one motivation for me to start this was also that. It's that it's the way I'm working on this. I really like working on this, it's fun. But long term, if I think 5 years ahead, it's just not sustainable. So there needs to be a way to kind of get reimbursed. And this is a common problem for all open source developers. I think you will all have faced this. So if the prices seem unreasonable or too high, well, we have our reasons for those, and we can also discuss them. So they're not fixed. They're just the current idea. And we also have some more expensive ones which are intended for business use. And there you can avoid the VIT if you give us an ID. So this is all checked with my accountants. It's all fine, it'll work. And we can also host you on more expensive servers. So the idea is not to just serve end users, but also people who are actually developing software in work context. Now, we don't want to earn money as much as possible. So if we can reduce the cost, and if there are ways to reduce cost, and if you see ways to reduce costs in what we're doing, then we can take the feedback and revise the tiers. We can restructure them, we can have more or less, we can change the names, we can change the numbers. I don't care, as long as hosting costs are covered, and ideally we reach a target where our developers can be sure that they can invoice at least collectively 1,000 euros per month. Maybe 3,000 would be nice, because that would actually make a big difference. But if we had this money, then I would no longer be working on this in my free time. And this would make a big difference in terms of making progress, getting all these features implemented, and actually making the site much more useful. And with the current tiers, we need about 130 regular users or 40 business users to cover this. And currently we have 3 users. We have more people who are paying on the Open Collective page and donating because they like the idea than people who are actually using it. I don't know if that is because of the lack of functionality, because the web front end isn't there, because the code review isn't there, or if it's simply because people are happy with what they have. And also I know from a lot of experience that switching code hosting is not something you just do like that. We will need to catch people in the moment where they're like, I'm starting up something new, or I'm unhappy with something I'm using. And most people who already have something that works for them will just keep using that. It's no problem. That's expected. So we don't expect to be growing exponentially or whatever, but we hope that we find enough people to eventually reach, maybe within 1 or 2 years, this amount of money to support the project. So how can you actually book service? You will need a credit card. It just makes a lot of things easier, simply because my company is responsible for all this stuff, and if you have a credit card, you're probably not underage, you're probably hopefully not using a stolen one, and so on. So, and also I don't want to really expose the bank account numbers because they can be easily abused. So at the beginning I used to accept money directly to the bank account, but it's just, there's too much abuse potential. So even though I'm not happy with requiring credit cards, it just solves so many problems. That is the only sane way for us right now to run this. You can send email and simply tell us which tier you want, which subdomain name you want, the usual username, public SSH key, that's all we need. And oh, did you know that SSH accepts email addresses as a parameter? It does, it's true. So you can do that. You can SSH to this email address, and you can talk to our entropy-driven chatbot that will handle the registration process for you. And it'll give you a link that you would normally get by email that allows you to directly book the service to reinforce our need to provide your VM right away. And these are limited, so please don't get links if you don't intend to use them. It's not a real problem if you do, but because we want to kind of control the influx of people, we have so many links in the database, and once you see a link on your terminal, it's removed from the database. And so if the links are all gone, I will have to go and generate more and put them there. Just takes 5 minutes. I have a script that does it, but please don't just don't get them for fun. Okay, so I have two parts to this talk. This was more the general, what's the intention, what's the idea? And if we have time, I can dive a bit into the technical details of how we do deployment, which might be interesting to some people. Any questions so far before we dive into technical stuff and for the last 10 minutes? Yeah?
You mentioned that you disabled browsing the repo publicly, so you first need to get this cookie thing. But that's the 10-minute time. But that means that you're not getting indexed anymore. I see that this is a big benefit for resource consumption, but there is a downside to it, and that is that you're not indexed by
Right. Yeah. If you enable the statement is that if you enable the authentication, you're not getting indexed. Now, this is fine for private repositories. It's what you want. And the hack that we're using the anonymous user to prevent the crawling is just to prevent the crawling. You're in control whether this is allowed or not, and you're in control of whether you publicize the repository or not. You can set this. We're not going to require your use of this feature. It is just that if you have repositories where you think this is okay, you can set the authentication not just per server, but also per repository level. So you can go and you can change the permissions of some repositories to completely public by disabling authentication on them, and you can require it for others. Does this answer your question a bit? So you can say, if this is public, it will be indexed. It's no problem. Okay, so how does this work? When you book service, we create a subdomain for you in DNS. This is not automatic, partly because we do moderate the names somehow. If some person comes and says, I want derad@github.org, I will go and check if it's really Theo who wants this domain name, for example, right? Also, if you're trying to use company names or whatever, and you're not that company, we'll say no. If you have a sign-up link already used and already booked, and you have a problem like this, it's no problem. We can refund you if you're unhappy. But please consider this when you pick your names. We don't want people to misrepresent anyone. You get a VMM virtual machine on an OpenBSD server, which we rent as a root server, a physical machine. You get an initial configuration, which is just a simple gotsys git, and your public key can clone this. You initially have only one user. This is what the system we built for deployment looks like when you do ls or tree. You don't see that. You don't have to deal with that ever. It's us who deal with this to be able to deploy VMs efficiently. So it's a bit like the ports tree. And you can see that there's two sections. There's the base image section where we build images that are OpenBSD installations into a single QCOW2 image, which we then use in the part below. So T0 there would be the test server that I'm using, and T0A and T0B are two VMs. And they would refer to the base image as the OpenBSD system that's being booted. To declare a VM, when you send us a request, we go in, create a new makefile, and much like a port, we say which parameters this VM is supposed to be using. And you can glance a few things from this. So for example, that we're redirecting SSH and PF to each VM, and so on. And you also get an SSH port. The system is designed such that a server can use one public IPv4 IP to serve all the 40 or 50 users who are on it. And each one will have a specific SSH port. It's a bit of a hassle, but it's not a big deal, because SSH is now encoding the port number in the non-host file. So you will not get confused with other ports. Even if you have several of them on the same server, SSH will know which one is which. IPv6, well, if you have that and we have that, then you don't even need to specify the port number, because we can just forward directly, because each VM gets a public IPv6 address. Well, they have private ones because it's easier to do the mapping consistently between all layers, but you can reach it as if it was on public IPv6. So we can patch the VMs that are running individually if you want, but usually what we do is that we create a new base image for any change we make. Even if GOT is updated or some syspatch happens or something, we just go and build a new base image. And we also we have a custom port of GOT for this. So there's the devil GOT port in OpenBSD, which is not the same as what we're running here because we want to be able to deploy fixes quickly without having to go through the OpenBSD ports process, waiting for packages to be built over the next 2 or 3 days, and then being able to update. It's more the other way around. We commit patches to the main repository, and then we cherry pick them into this port from there, and they will eventually be released and become part of the official tree. So even if you're self-hosting, you get the same stuff, you just maybe get it a little bit later, but we still try to support you. The base images have version numbers because if you use QCOW2 base images and you boot a derived image with the wrong base image, it's a disaster. It just crashes the kernel and everything goes wrong. And for deployment purposes, there's an SSH key which goes to root for each image that our scripts are using. And it will eventually be deleted, so you can't actually SSH to root in the final VM. Each VM has 4 disks. This is actually a limit in VMD. I was told it's a bit arbitrary, but I found I fit everything in there. So the root disk is the base image, and basically this is a QCOW2 that's layered on top and this does copy on write. So the base image that all the VMs are based on is read-only, and their custom disk blocks get written to this other file that the VM is actually booted with. You have /temp, which is encrypted, so that when GOT unpacks your blobs or whatever and stores them in /temp, decompresses things, and there might be plain text data. We don't want that to be, even though we use full disk encryption on the physical server, we still don't want data to be exposed unnecessarily. So on each boot, we re-encrypt temp with a new key and mount it. There's swap space, of course, and there's your Git disks. Your repositories are there, and also the SSH host keys of the VM, because when the base image is rebuilt, it has a fresh set of host keys. So we need a way to keep the host keys consistent when we upgrade. So the Git disk is actually permanent. It's never overwritten. Once it is installed in the /VM directory, it never gets replaced. The other ones we can throw away. We can regenerate all of them. So this is what I would do if I upgrade a VM. I just build the disk images fresh. I stop the VM because we want the Git disks to be shut down. And then I do make install, which replaces the base image of your VM with a new one. And I can even do this for several VMs at once by just going to the upper directory and running make targets there. Then you go to a directory which generates host side configurations that are needed. For example, pf.conf needs to be told to redirect ports. So each VM directory provides a snippet for pf.conf, which gets picked up here and put into the final pf.conf. And the files are staged in the current directory, and then when you're happy, you run make install. And it doesn't ever touch the running stuff, but you have to manually reconfigure the server to pick up those changes, and then restart the VMs that are currently stopped. When the VM boots, it finds itself with a new base image. This base image has a new password file, which is now empty. It has an empty home directory. All the stuff is gone that was there before we upgraded. So we need to do 2 things. We mount the Git disk. We get the SSH host keys out of there, which are on the persistent disk. Restart SSHD so that you don't get certificate warnings if you reconnect. And then to do anything else, we just tell GOTSSD to please redo system configuration. And it'll go and it'll recreate all the users that are missing, install all the authorized keys that should be there, basically has an empty world and rebuilds it. And now your VM is running in the same config as before. I did some testing with upgrades and so on, and it really takes like 30 seconds to do all of this for a couple of VMs. So the downtime is really short. It's much shorter than upgrading OpenBSD the traditional way, because you only have the short time where the VM is stopped, you replace the images and restart things up again. And it boots and redoes its config, and then once it's there, it just works as before. So that was the reason why I decided not to run package.-u and all the stuff individually in each VM. If you have so many machines, like we're expecting 50 machines per server, it's much easier to use something like this. Okay, last slide. This is an extra. I just put this in case we have time for it. We have 1 minute. It shows you how to get started. You clone the gotsys.git from your new VM. You add a repository. You commit the change. You do git push. And at that point, the URL of your repository is a valid git remote. So you can go, it's empty, but you can go to any git repository, add the remote there, and push to it. And our server will accept the changes, and then you have your project up on our VM. You do this for all your repositories and populate the space, and everything works. Okay, 30 seconds to go. Who wants a sticker? Do you have a question?
I do.
Yeah.
I like the top questions, but microphone. Thank you. The VMs that you're running, is that using AMD CPUs, and do you use the...
Currently, yes.
Yep. Cool.
Currently, we're focusing on, so the idea was to use Ryzen-based servers for the regular tiers and EPYC-based for the business ones. This will only matter once we have enough users to justify running more than one server. The current server is at Hennings. It's an EPYC. If you book things now, oh no, maybe it's an Intel one. I have to check again. But anyway, we have a server that we need to fill up before it makes sense to rent another one. But the focus is on Ryzen and EPYC for sure for deployments.
Right, so you're currently not supporting the AMD SEV?
Not yet, but we could look at that, certainly.
Yeah, cool, thanks.
We would just like to gift you a tie, and then we'll move on to it's a Croatian.
Thank you.
Apart from the fact that I myself need a private Git repository, and I'm going to submit my subscription probably, how do I advertise you? Because I know quite a lot of people, and not everybody is in this room, so you clearly need a salesperson, I guess.
Well, we have the website, gotup.org. We also have a Mastodon account where I've posted a bit of things. There was a talk at BSDNL last year, which I did about this. And I'm not really great at advertisement because I'm not a marketing person. So I'm kind of hoping that word of mouth will spread over time. And because I also know that it's not an easy proposition for people who already have something that works for them, they will probably just use that. It's fine, you know. And I'm also not trying to get as many people as possible if they don't want to be there. I want people to come to us because they want to be there. And yeah, spreading the fact that this exists alone will probably help. But I don't see a need to pull people away from Git. I don't see a need to pull people away, especially from services like Codeberg, which are doing a great job at filling, especially solving people's issues with traditional hosting services. And yeah, I don't want to steal their cake, right? SourceHut is fine too. I don't want to get users off of SourceHut to go to this. I want people to come here because they like the design, they like the ideas, they like the project, and it's useful for them. And yeah, some things we can do differently than the others, and I think it's good to have lots of alternatives. There should be more services like this, because the monoculture right now is just bad. It's not a good state to be in.
I mean, but you don't want to capture people from elsewhere. But at the same time, as you said, the presence of people hosting repositories in your project is vital for the future of the project,
Right.
for the prospect.
Yeah. Yeah, but you know, I said, I calculated about 130 people. That's much less than Codeberg has, right? So we don't need to be big.
I wonder whether an automatic promotion between tiers could be implemented. For example, if I'll start occupying more space on the servers, so how is it implemented right now?
More space?
Yes.
It's possible. So currently the disks that are on offer on the rental services are about 1 TB or 2 TB in size. It's also a question of how fast you want the disks to be, because if you get an NVMe that's smaller, but much faster, it will be a lot more responsive. And also another concern about space is that we provide backups. So if you read Codeberg's terms of service, you will see that you're responsible for your own backups, for example. If they crash and lose the data, it's gone. We don't do that. We have copies of everything separately on a dedicated server, potentially multiple dedicated servers eventually in different locations. Because if you use something like this and you rely on it, then you need this kind of reliability, especially if you're paying for it, I think. So backup is included unless you don't want it. If you don't want backup, you can ask for twice the space, because that means that we don't have to allocate the space. So when you see this much space is provided, it's not just provided on the VM, it's provided in backup storage. And that makes a big difference. Okay, we're done?
Okay, thank you. Unfortunately, we don't have more time for questions.
Okay, you got the stickers.
Alexander Blum. I'm working in the OpenBSD project since 2007 or so. I'm employed by the company Genua. We build firewalls based on OpenBSD. So network performance is something which is important for us. So in the years, say 10 years, I'm working on OpenBSD network performance. And there, the obvious thing that you should do is make it run on multiple CPUs in parallel. So I'm talking about this topic today, so I'll explain the history. How does this MP work in our BSD systems? How do the packets go through the kernel? What to do to measure the performance, to see where we are, where we want to go. And then a little bit about speed, what I've achieved and what could be achieved later. So this is a classic BSD kernel. It has some userland here running on top, doing some system calls. The kernel is divided in two halves. The top half is there to serve requests by the user, and the bottom half is there, it's here, when the hardware has something to do, like an interrupt, says, oh, do something for me. So when a packet from a network comes from here, and if a user says, send something to the network, it comes from here. Then we need some sort of protection, and the very old BSD style thing was SPL. It was developed on the VEX. And so here we can block interrupts. So when we do something in the network stack, in the top half, and there comes a network packet that says, oh, now I have to do this, bring me something in, then it would create chaos if it just interrupts somewhere. So we can block the interrupt with this SPL. Then it might also be blocked in the hardware or not, depends on the architecture, if that's software implemented or even hardware implemented. But the key part is when you are running here, you don't get interrupts from here if you set this SPL level. And that's all protection we need on a single CPU system like the VEX was. So this SPL is also a question of prioritizing interrupts. We have disk interrupts, TTY interrupts, network interrupts. So basically I'll speak about SPL net, which is for the network interrupt, and forget all the others. But there was a problem. So when the network stack was doing TCP and blocking everything, we still wanted to receive network interrupts because network cards were time critical before they had large DMA rings. You must be fast to get out the network packets, perhaps with I/O instructions. So when you do large TCP, whatever window calculations, then you still want to run network packet processing. So it was divided in softnet and net. That was in the 90s, where we protect our top half with a softnet SPL level, run the network stack here, and the network stack itself protects it with SPL net, where it actually gets the packets from the driver layer. So when we do some heavy TCP things here in the softnet, we can still get interrupts from the card and just take the packets and queue them somewhere to be processed later. The reason why I explained it here is that a softnet is still the layer where we all do the upper protocols in our IP stack. So and then in the 2000s, OpenBSD went MP. I think it was the last of our BSDs who did that, and the way more or less all Unix systems did that is by using a kernel lock. So this part here is unmodified, so on one CPU you run like you always did, and now you want to run, first of all, user processes on other processors. So you want to have a userland here, and a userland here, and if they just run in userland, there's not much to do in the kernel. You just have two schedulers, and one processor is scheduling on one CPU all the programs and the other one on the other one. The problem is what happens if this user land wants to do a system call. And you have all this top half here. You don't want to modify everything. You can put locks in everywhere, but you want to run it in parallel without caring about fine-grained stuff. So what you do is you put a big lock in here, and if this guy does a system call, this one is not allowed to do a system call. You just block it. And also your interrupt handlers are blocked because they also take the kernel lock. The first thing what an interrupt handler does is take the kernel lock. What all system calls do, take a kernel lock. And this way you can just run on a second CPU all the user lands which do system calls there, unless the other side, oops, wrong button. Unless the other side does a system call or an interrupt. All the interrupts still run on CPU 0. There's no interrupts on this CPU, except some inter-process interrupts, but we can forget about them. So now I want to run the network stack somehow in parallel. And what we already had before is this softnet. And the first idea was to replace the softnet SPL system with a network lock. So that's the net lock here. And this is a read-write lock. So it's an exclusive lock. If you come from a system call here and want to do something with a network stack, you take the net lock. It's an exclusive lock. And if the interrupt driver here says, oh, we have a packet, you have to process this, do some IP input with it, we also take the net lock. The driver thing here still works with the kernel lock and the SPL as before, but we can extract part here, your other system calls here as we always did. So the thing we went in small. OpenBSD is doing a release every half a year. And every half a year, and even the system was stable. There was not some huge, oh, we convert everything in one thing. But next thing we did. So as I explained before, the kernel lock is taken by every interrupt and by every system call. And what we introduced is MP-safe flag for system calls, which means that you don't need the big kernel lock, but this system call is MP-safe, and you have to care about your locking yourself. So what we did is declaring it MP-safe and taking the net lock. So when you have network operations here and here, the net lock prevents that they run in parallel. But if another process on your system is doing some regular system calls like file system or getting some interrupt for some whatever hardware, not network, then it can run in parallel on this CPU, while here, where we want to have two network system calls running, they lock each other, but not this one. The network driver still uses the SPL. We haven't changed that here. So that was in 2018. So here, MPI started with it, I did some things, MVS did a lot of things there, getting the kernel lock out of this part. In parallel to that, DLG was working on the drivers, and modern hardware provides multi-queue features. That means usually you have two queues on a network card, one for receive, one for transmit. The receive queue you fill with empty mBufs, and the card fills them with during DMA with packets, and then gives you a receive interrupt, says, okay, here, take your data. And transmit, it works similarly. There the driver fills in the queue, and then it says the card, okay, here's the data, send it out, and when the card has 3 slots available again, then it gives you an interrupt and you have to refill it. And there's the feature multi-queue, so you have not one queue, but you have a lot of them. So the feature, I think, comes more from the virtualization idea that you can pass through parts of your network to virtual machines, which also means that the hardware has features where it can analyze the content of the packet, like IP addresses and ports. And so you can can program the card to direct packets that go to this IP address on this queue and to this IP address on that queue. And also for MP, that's very useful, because you have you need a mechanism where you can push things to multiple CPUs. So when you have multiple CPUs, you can either have multi-threaded programs or multiple processes running here and getting the pressure down, or you need both. And the other side is you have hardware that can split the things that come from your one network cable into multiple queues, running it and trying to get it to multiple processors so that you can run it in parallel. Another thing is important for TCP, reordering is very bad, because TCP stacks things when packets get reordered. Some queues in the routers were full and packets were dropped, and we reduced the speed. So never reorder packets, TCP packets. And then we come back to this mechanism where we split, where the hardware here splits the packets to the queues based on IP addresses and ports. So basically, they make a hash over this four tuple, and say, okay, this portion of a hash goes there, this portion goes there. So all the packets that belong to one TCP connection goes to one queue, and the others go here. And so we can run multiple TCP connections on multiple cores, but each core gets all the packets for one connection. So MSIX is a mechanism in the PCI bus, where one device can have multiple interrupts, and you can deliver them to different CPUs. And now we need some mutex to protect those queues. Usually when you go from one locking layer to another one, you put a queue in there. Here we have an input queue for the packets, or an output queue, and both are protected by a mutex. So either the driver can access this queue or the network stack. So what we did next is unlocking the receive and send path. So receive and send are the performance critical things that, so I'm basically working on throughput, because that's the obvious next goal. So send and receive were on the top priority list. And here, the system call was rid of the kernel lock already. That was 2 slides before. But now we want to get rid of the net lock. See here, the net lock is not there anymore. What we have is that between here and here, we have socket buffers. We have a socket buffer to receive, we have a socket buffer to send, and we put mutexes on the socket buffer. And that way, the system call can put the packets in the socket buffer, and if the network stack wants to take them out, it also gets the mutex of the socket buffer. Out and in, both ways works the same. You need a receive or send socket buffer. But you still have the netlock which protects the network stack, but not the system call which puts in the packet here. They only need the mutex that's specific for the circuit for this receive or send buffer. So with all that done, especially with the driver being MP capable here, I started to do parallel forwarding. So when you do forwarding, you have the IP stack, and IP forward just goes here within the kernel. There's just the packets that come in here, go here, and are delivered there. And I started by running this network stack in 4 threads. Before it was only 1 thread, because it was locked exclusively anyway. Doesn't make sense to have 4 threads and one lock. It makes sure that only one runs. This read-write lock has a special property. It can be exclusive or it can be shared. So what I did is, so this all this thing, this UDP TCP protocol was not touched yet. So it was not able to run somehow in parallel. So this one kept the exclusive netlock, and this one got the shared netlock, which means when you have some TCP action here, none of these threads is running. But if nothing is doing TCP or UDP here, you can run 4 CPUs doing packet forwarding. So that was achieved in 2022. And now we also get some pressure on PF. So we started with PF having one big lock. Now I think we have a rule lock and a state lock. It's a little bit more fine-grained. More could be done. I've chosen to have 4 threads because it was not perfect yet. So I just want to have some parallelism, but not going full scale on all CPUs. The drivers here typically have 8 CPUs. It also depends on the hardware, how much it supports. There are also one who only have 4. Here, I'm trying to figure out what's an optimal number. So it's not the case that when you just take the biggest number, then it's the fastest. That's not how it works. It needs a little bit of experiments. So next thing I did was unlocking UDP. UDP is simpler, so I did it in 2024. And TCP, I did it this year. It was in June or May, something like that. Or even a little bit before. I did it after unlocking, so May, I think. So now what I do, I have those receive and send buffer locks. We have a lock per socket lock, and especially for TCP, there's a lot of state in this socket. So you have it's not just the socket structure. It's 3 structures. There's its socket, its internet layer, and its TCP layer, but they are locked together. So that's the socket lock, and it's per socket. That means when you run TCP on the same socket, you can only run it here. So if you get an interrupt here that says, oh, process this TCP packet, and then somebody says, oh, well, we want to send some packets on the same socket, then one of them is blocked. But if you get it to one socket here and the other one wants to send, then it works in parallel. So you need a per socket lock to work on all this TCP state. And to get in this upper layer, you additionally have those send and receive buffer locks. But it's just, or we put in something in the buffer and get it out there, and it's also some state locking on the buffer, which is done in this layer. And what I did now is, as here is not this big netlock anymore, I've chosen to have 8 threads in the network stack. I'm experimenting to take a higher number, but you always have to look where are your limits, what can your network cards do, how does it scale, and I'm a little bit conservative. First I want to get it stable, and then I want to figure out how fast is it. What are optimal numbers for my hardware? By the way, this is just a define in the kernel source code. If you want to try, set it to a higher number and look what the difference is. Okay, this is the hardware where I'm doing one kind of performance tests. So what I have here is a Linux machine where I generate the traffic, one OpenBSD box, next OpenBSD box, another Linux box. For example, for IPsec, I need both of them to encrypt, decrypt, and receive. For forwarding tests, I only go through one of them and then to the other one. But I also do OpenBSD to OpenBSD. That's a common thing I do. This hardware was left over in the company. I could just take it, put in 10 gigabit network interfaces, and it's point-to-point cable, so I don't have any problems with switches. We had some other performance setups from some hardware guys, and they had switches and things and that, and you could always debug the infrastructures and never got a reliable result on the OpenBSD, so I rebuilt everything from scratch. And what I do now is that I do daily measurements since 2018. I check out the kernel, build it from that day, do 5 test runs, because then you see how much you have difference between each test, and you see how reliable it is. Here the color changed, so it's 4 different tests with different number of parallel streams, with the direction going this way and that way. And here I somehow changed the test script a little bit, so I changed some parameters. So the GNU plot decided to use a different color. So this one is, I think it's the same color. And here the difference is that is running 10 streams, and the yellow one is running only 1 stream. And here you don't see the blue one because GNU plot decided to make the yellow dots on top of the blue dots. So I started here, and the first thing that happened was, oh, performance is going down because we had some meltdown spectra protection in there. Then we ported witness from FreeBSD, and someone had the idea to enable witness in the generic kernel, and that's this one. We enabled witness, and then we disabled it again, so it got faster. Not sure what here happened. Here somebody tried to fix the time, or to make the timer implementation more intelligent. Then the TCP timers got really confused, and I said, no, back it out, and then we got the original performance back. This is an experiment from Jan. We have an algorithm that sends we have delayed X, but we don't delay every second egg. So every second egg is sent immediately, and all the other, the first egg is delayed for up to 200 milliseconds, I think. But you can remove that. So you send less eggs because you always delay all eggs, and then you get this performance increase. The first try of Jan's diff was wrong, and then we ended here. Here I decided to back it out because it was breaking some of my regression tests. Also, I had some, you don't see in this resolution, sometimes it got slower here, and there's a research paper from the 90s that you shouldn't do it, and maybe I do it anyway, but I have to fix all the bugs first. So here you see the width of the graphs. That's always five test things, and here it gets wider. So what I did here is this parallel forwarding. So I run IP input in parallel, and every time when you run something in parallel, your measurements are more spread over the spectrum. So the bottleneck, of course, is TCP, which is still running on 1 CPU, but the parallel might be a little bit faster, but also more diverse, the speeds. So then we added TSO, TCP segmentation offload, where we generate very large packets in the TCP stack, pass it down there, so the IP layer, the PF layer has less work to do, give it to the network card, and then the network card takes the 64K packet and converts it to a sequence of 1.5K packets. This increases the overall performance a bit, but you also see it makes some tests faster and some not so fast, for whatever reasons. Here, MVS started to put all those mutexes around the socket buffers. So when you start adding locks, it gets slower, unless you run it really in parallel and take really advantage from those locks. But we added those locks very slowly and carefully, not to create deadlocks and panics and whatever. So it was, until here, it was only making it slower by adding locks. And usually I can, when I want to figure out, oh, what happened here, I can configure all that it checks out every commit and makes a measurement for every commit between the 1 day period. So I can see, okay, this commit caused that. And here I couldn't find a commit. It was, the speed is going up and down anyway all the time, so it's hard to figure out, is that yet for real or not? But it always goes a little bit down and cannot say, okay, here, that's a problem. That was not possible. So and what I did here, I added parallel TCP output. It's the output path. So when the packet goes out, I make it faster. And here I made the TCP input in parallel, which is the real bottleneck. So input is the hard part. And here you have to remember that. I'll explain later how that happened. Here I added a lock per incoming TCP packet. And having one lock per packet is always a bad idea. And here I added, so what you see when you have single stream, that's the yellow one, that goes down. And if you parallel stream, that's the blue ones, they go up here, this one. But I had some problems with single stream, so I had an idea for that. I'll explain it later. And then with that idea where I queue the packets together in a queue before I take the lock, then the TCP parallel output even is faster. So that's a 10 gigabit. It's 10 gigabit card and never gets faster. And I had to remove the problem that was here because then the single stream was also at a decent speed. And yes?
What's happening with the green?
So the green one, that's just some, I don't know, it's just some artifact on the slide. Okay, now I go into the network stack. I had this similar slide previous year, so you all know it already. So packets come from the device driver. Here's an input queue, TCP input, IP input, TCP input, receive buffer, socket. That's the input path, output path, socket, send buffer, TCP output, IP output, output queue, device driver. If you have forwarding, we just go from IP input to IP output. So what was parallel before I added parallel TCP input? So from the history, every time where there's a double arrow, it was done at some point, and only TCP input was left. That was the final thing. So we have the shared netlock here to run forward in parallel. We have some routing locket here. We lockless routing, and DLG rewrote it recently. We have some multi-queue here to make that fast. We have those receive buffers to protect this one. And here we still had the exclusive netlock, so when TCP input was running, all the others were blocked. So the first thing I unlocked is UDP. UDP is on this side. In UDP, I just figured out that nothing is left unprotected here in UDP input. And then I just called IP input and UDP input and don't care about this protocol queue anymore. So you don't queue it here, just call it, and it just worked. UDP gets a lot faster. So and then the next idea was, okay, let's do the same for TCP. First I had to fix the SYN cache and the timers and the output and all the things where something could happen, and then only TCP input was left, and it had a socket lock, and fine, and so on, and this was my first thing. So here it's running in parallel, and now I saw, okay, it gets slower, especially the single thread performance dropped. And the problem is that every time when a packet gets in, here, we send an ACK. And then userland, or not this userland, when the userland takes the packet out here, you get a window update, that's the window update. And then TCP output is called, and it's also taking the socket lock. So we have the socket lock here for every packet. And we have, then the userland is informed, and we want to have the same socket lock on the TCP output to send the window update. And this way, they are constantly fighting. And the fight between taking the packets in and getting the window updates out killed the performance. So the question is, how do you see that? How to figure out what's going on? So what we have btrace. It's not as powerful as in Solaris, not as good as in FreeBSD, but it's good enough for me. Well, and I get out those kernel flame graphs. It's stack traces from the kernel. It works the way that we generate a timer interrupt 100 times per second, and we record the stack trace of the kernel where we are right now, and then we count how often were we there. It's running for 1 minute, and then we make a flame graph on the number, how often we were there. So that's the exclusive netlock single stream. That's where I started. And this one is the one where I had the performance problem. So it's running in parallel. No, it's not running in parallel. It's a single stream, but it takes a lock per packet. And what you see then is that here the read-write lock is taken, and here is the read-write lock is taken. You only see it when you compare it this one and look at everything, and you see everything when something is flat here, it's not good. And when you zoom in a little bit, you see that's a read-write lock, and that's a read-write lock, and that's a socket lock, and they were fighting with each other. So that's the syscall read, that's the input, the reading part, the userland, and that's here is IPv4 input, TCP input, that's the part from the network layer which causes problems, and so they fight, and so everything gets slow. So what I did as a solution was that I cached the lock. So I put in, so here I do a little bit delay. So if I get a packet, so here the input task takes everything out of this input queue. Then it figures out, is it TCP, is it for us? And if it's for us and it's TCP, it usually calls TCP input, but I don't do that anymore. I put it in the queue, and the queue is per thread. So the network thread is running, has a queue of all TCP packets. It is processing when it's processing this queue. So we sort them all there. And then we can do the UDP part and the forwarding part immediately, and we have a queue of all TCP packets. And when we have finished, when this queue is empty, then we look at the TCP packets, and we take the lock. So we process, take the lock of the socket, but we keep the lock. Then we look at the next packet. And if the next packet is for the same socket, we already have the lock. And if the next packet is for the same socket, we already have the lock. And it's very likely that the packets belong to the same TCP connection, especially when the other side uses TSO and has a huge packet and does it, slides in small packets in a run, then you get all of them more or less simultaneously. So you have this bunched TCP things, at least in my performance tests. Who knows what is in real life? And there, the problem is just solved. If we keep the locket while we run over the TCP list. If the packet belongs to a new socket, we give up the lock, take the new socket lock, and then process all the packets that come there, which probably belong to the same packet, to the same TCP transaction. So we keep the lock here for a longer time. So this socket has to wait with its acknowledgements, but this acknowledgement sending does not affect this one as much anymore because we hold it longer here, because we delay the TCP packets. So this is the old thing that I had before. Here, just at the lock, you see every time you take a lock per packet, then you lose 4% roundabout. Then this is the one that didn't work, where the single thread performance went down because I take just do parallel input and take the lock for every packet. And the parallel goes up, but still doesn't reach the maximum. And here's the fix I described. So single thread performance goes up a little bit, but the parallel performance is even higher than there. And you see it's still spreading a lot, so that's basically running the same test, and sometimes it's fast, sometimes it's slow. When doing MP, I always see that. Apart from all the other phenomena where I don't know why it happens. So what I do now is make the flame graph. So I have this socket per lock per thread, and I run it in parallel. So this one is idle. You saw the huge flat thing before. That's idle, where CPUs don't have to do anything. So what you want to do is getting the idle small by running a lot of streams in parallel and making sure that nothing interlocks each other. And so is that 10 minutes? Okay. So and here you see that a lot of things are running in parallel. The things that you see here above that are the interrupts that are just come in between, and so what you want to avoid in those pictures is those flat things. It's having idle, and here we do copy out. You cannot avoid it. You just copy the data to userland, and you have to do it. So now I have new hardware setup. So now everything goes to 100 gigabit. the hardware generation changed, and now we have the network slots ports in the front, so you see immediately how it's cabled. Now I have such graphs where I run multiple interfaces and hosts, so those are all hosts, and they run in per cron every day, so I can compare what happens on virtual machines, what happens on hardware. And I have several network interfaces, so I run on the 100 gigabit Broadcom, 10 gigabit Broadcom, 100 gigabit 1 gigabit Intel, 2.5 gigabit Intel, 100 gigabit Intel, 10 gigabit Intel, 25 gigabit Intel. Well, that's a virtual KVM. VirtIO, I run it on VMM, on OpenBSD, on KVM, on Linux. And VMX was the VMware driver, but I don't test that anymore because our license expired. And we were dropped out of the partner program, of course. So, but I can also can modify the things. I can run jumbo frames. I can turn off large receive offloading. I can turn off PF. I do that to figure out if there's a performance difference, and it doesn't matter. Sometimes PF even makes it faster because we cache the socket at the state. But sometimes you see, okay, PF is the bottleneck, and I just want to see, does the network run even without PF? And I can turn off the TCP segmentation offload, where we make sending TCP packets, send TCP packets smaller in the network card. Then I can add some pseudo devices. I have bridge, carp, GIF, GIF6, GRE, web, VLAN, VXLAN, VG. VXLAN is not very stable, VG is very slow. These have not been unlocked yet. I added trunk. Those slides are 2 weeks old, so now I also can test trunk. Trunk is not slower, carp is not slower, bridge is running. It has not been unlocked, but we have this new web. Web is also a bridge, but by DLG, which runs in parallel, so this one is fast. I have 93 test cases which run on ICMP, just some pinging, TCP, UDP, socket splicing, multicast, iPerf. I try to integrate T-Rex and get that running, but I'm too stupid for that. So I can run that on several platforms. I have AMD CPUs, I run it and Intel CPUs, I run it on VMD, have KVM and QEMU, run all of that with the SEV setup, so I can see if the network performance on SEV works and what the impact is. I had it on Spark 64, but I lost some rack space in my lab because we were moving around, so I disabled that for now. And VMware, as said, no license, no tests. So what I get there, so it's just a small fraction of my results. So usually people get totally confused. It's a really huge web page and all those numbers, and we scroll here and click there and see that's the performance, and nobody else sees what I'm doing there. So I'm not a usability guy. So what I run here, those are the names of the tests I'm running. I can run V4, V6. Here I have some UDP, multicast, TCP. I do forwarding, splicing, copying, receiving, sending, do parallel streams with 30 parallel streams from multiple Linux hosts, and here's iPerf from one, and I here do TCP bench. TCP bench, by the way, has the problem now that it's not multi-threaded, and one userland process is too slow to get enough pressure in the kernel, so I use this iPerf. So I had Debian, there needed to get a special version of iPerf because the old iPerf for the old Debian didn't use multi-threading. But I updated the Debian now, and that's fixed. So another thing that made us faster, not on the slide with where we had the daily checkouts, where the TSO and the LRO, because the hardware is too old to support LRO, but the modern hardware supports it. As that's the version from 2010. So the large receive offloading is in the X driver, and the VirtIO driver, and in this VMware driver, and So Stefan has a diff for the BNXT driver, but it's not quite ready now. So because newer Intel driver don't support large receive offloading anymore, we do it in software now. So the idea is when we have the DMA ring filled and get an interrupt, then we just run over all packets. The card gives us a hash, which TCP connection this might be, and then we look at the sequence number, and if they match together, we glue the packets together in the driver level, and then they only get us one huge packet through PF to TCP input to IP input, and that makes it really fast. Stefan also has made this for BNXT, but I made the slide 2 weeks ago, so it's not there. So the TCP segmentation offloading, it's very common in hardware, so all those drivers support that. And if the driver doesn't support it, we have a software implementation. So when you do LRO and take the huge packet and you forwarded it, and now you want to get it out, and you see, oh, we have EM, oh no, EMS supports it, but we have some driver which doesn't support it, then we have a software implementation which makes small packets out of it and sends it out. And even with the software implementation, it gets faster because you run through IP input and PF only once with a big packet, and just before the driver level, we split it up in small packets. So that's some measurement. So I use socket splicing here, which is used by the RelayD, which is a special mode to get the data from one socket to another. The reason why I've chosen that is because we built an application level gateway which exactly uses that technology. So in the OpenBSD versions I've chosen here, that's the stable line of our product. So we have GNU-Gate 10, and that's OpenBSD 6.6 because it's a long time solution. And so we can show the customers, so that are the relevant versions for our customers. So that's the long time revision. So I translated that to OpenBSD. So this is the one that we currently ship if you don't need certification and long-term support. And that's the one OpenBSD will release next month. And that's where I am. So this is the very old system. That's what we can ship now, which is also 1.5 year old OpenBSD-wise, because we have to merge it, and we have to edit, and we have to release it. It takes a while. And here is that what we will ship in OpenBSD next month, in GNU next half year. That's this one. And then we connected the Linux machines directly to each other, which shows there's not much left, and I have to improve my test environment, because usually you want your test environment much faster than your system under test. So Jan did those measurements for our marketing department. So, and then, the final slide. You have to know what you are optimizing for and what you are testing. So I had the idea, okay, so what I was doing before was mainly iPerf and just getting traffic through, and it's still optimizing for throughput. And then I thought, okay, I need something else, let's try this T-Rex. And I didn't find a stateful TCP test that does throughput in T-Rex. Perhaps I just didn't understand all this Python and C++ code, or it's just too complicated, or I didn't spend enough time with it. It was enough effort to get it compiled on a modern Debian. And so I gave them 12 pull requests, so now it compiles, but nobody cares about my pull requests. But I have cloned it, and I can run it on Debian. And so, but what I didn't get is this, they call it elephant streams, this huge downloads, and they only provide the possibility, or what I found there in all these undocumented Python scripts, a version where they send very short HTTP requests. So, and just run that against my setup. And what you see here, the bad things that happen. So we have CPUs being idle, nothing happened there. And we have here flat things, and here it's mutex enter, so it's taking some mutexes and just doing spin lock, and nothing happens. So when I get a 700 megabit, it's not giga, it's megabit throughput in this test. That's just a number that T-Rex says, and I have no idea why. But I know what's going wrong. So what you see here, that's the close system call. Here you have the connect system call. And here you have the socket create system call. And all they need the mutex in the, oh dear. So, but that's the final slide. And all they need the mutex in the PCB table. So this table contains all the sockets. It's a hash table, but when you do a connect, then you have to rehash it. If you create a socket, you have to enter it there. If you close it, you have to remove it. And if you get a packet, you have to do the lookup. Unless it's cached by PF, but the cache of PF doesn't work much. It doesn't help much because it's very short and it's not running on an existent state. So you have to do the lookup. So this part is doing the lookup. Oh, which TCP socket do I need? And this part is creating, closing, and connecting the socket all the time. And we have no data throughput. So when I use this test, the performance is horrible. So of course it can be fixed. You're just changing the algorithm, doing some more clever locking, and then then this will be faster. So the key thing is you first need a benchmark that matches your need, where you want to go. And then you make your kernel fast. And if you take a different benchmark, the results may be completely different. And then you have to optimize something else. And that's it. So here, yeah. Questions, maybe? Tom?
Just a quick question. How did it, is there any good place to find how to read those flame graphs and try and understand them? Is there any good, or is this kind of just something that skill you've acquired over time?
What is the
question?
Sorry,
how did you, is there a good place where you can learn how to read flame graphs, that someone can learn how to read those performance flame graphs that you were talking about?
They say the names of the functions in the kernel, and I know every function in the kernel what it does. So then you figure, at least those that show up there, and then you know what the kernel is doing.
Okay, cool. Thanks for that.
So the slides are on GitHub, and the bloomgenwa.de is the site where I publish all the performance results. The server is a Spark machine from 2000 running 500 megahertz, so that's the reason why it's not HTTPS.
Keep what you're doing, Alex.
Well, thank you. Oh, yeah. Thank you.
If it doesn't make the case, we can stop recording.